All right, it's a little toasty in here. I'm gonna crack the window. I don't know what would possibly show up on shorts if I did it, because I use a lot of my horizontal space. I expect people to not be watching vertically on their phones, right? So if I have YouTube automatically crop to a vertical format, what's that gonna do? What's it gonna do? I put these back together today. I found the bin that I stashed them in. These are the VKB pedals. Oh yeah, we need to start up YouTube chat. Hold on, wait. Before I do anything, auto find and activate. There we go. Cool. Now we got both Twitch and YouTube chatting in the same chat. Fucking freaking fight me. Oh no. There goes the YouTube feed, by the way. I just destroyed it by saying the F word. Very quickly, 2 seconds in. So that's the value that I'm bringing to you, YouTube. If you're out there browsing, perusing all of the different streams and stuff that exist in this wonderful platform, both YouTube and Twitch, and you are looking for a smaller size streamer who has enough chops to have quality video and audio, then you found them. That's this channel. And if you're looking for somebody to routinely just shoot themselves in the foot over and over again in order to not get as many viewers as they could possibly get, that's also my channel. Really, we could work on this thing, the board on my wall that burns subscribers onto itself automatically. That would be really cool because that brings in a lot of revenue. But instead, you're on a channel where someone's brother dropped off a new modern BMW seat and said, here, you can have this for your simulator setup. And so they launch hundreds of dollars into the internet and receive a bunch of metallic parts that they're then going to put together to put all of their giant man-baby toys together in one realm. This is a left-handed Warthog, Thrustmaster Warthog stick. These don't exist. Somebody made this for me many, many years ago out of plastic. They did all of the molding and the vacuum molding and stuff to make a beautiful rendition of the Warthog. Nowadays, I can 3D print this, but this was back before I had a 3D printer. We're going to put an analog on that, and that's, of course, going to get attached along with a bunch of other stuff, too. The mechanical movement looks really satisfying. Yeah, these are the VKB pedals. These pedals, they got this really satisfying movement, but they're meant to plug into a little box that's supposed to plug into other VKB hardware and no one else. So we were a little bit pissed off at these pedals because I like them a lot. They're very simple, right? They're just one additional analog axis to add to your setup. So with the two joysticks, I had, you know, X and Y, forward, backwards, left, right, tilt, and then vertical was going to be on the thumb, and it still will be. But that without a throttle is hand-on HOSAS, hand-on stick and stick. And it's really good for space sims, for like dog fighting and stuff. For dog shitting fighting. These were great for that though, because they're very straightforward. I mean, it's just helicopter pedals. There's a big plate under there and it has a roller on it with a giant spring that just holds all the force back. So you push one down, the other one goes up. Easy peasy. So when it came to unifying all of my sim stuff, we were looking at how this thing was communicating with a little box that it has. It's got this little orange here. Let me get it. Let me get it. It's got this thing. You just have an Ethernet cable between the two, and there's just one TX data line. It's one, I think it's just a one-way protocol. So there's just a TX line that leads to this little box here. Little box here just has a couple, like, what are they called? What's that name? UART. It has a couple of UARTs and stuff like that on it, and a main unifying microcontroller. It's meant to plug into the VKB sticks and the pedals and all that stuff and unify. Well, we don't want them to have a monopoly because I've got Thrustmaster parts, I've got Cytec parts, I've got VKB parts. So we sat as a man in the middle and we listened in on what this thing was communicating. It's basically a magnetic twist sensor and an AT-Tiny 85, which is just a very simple microcontroller. It's an 8-pin microcontroller. So it couldn't have been doing anything too complicated, right? Well, the bits that we were getting out of this thing, the ones and the zeros on it, were absolutely psychotic. It was this huge packet that seemed to have way too much accuracy. I got to the point where I got a 1-to-100 stepper motor, and I was going to hook it up to this thing so that it just spun infinitely, and we could record all the data in. because we were taking the data in with a very simple Arduino, just bit bang. If you see a 1, give me a 1. If you see a 0, give me a 0. And I had pages and pages of 1s and 0s that I was trying to decode. And what happened was it seemed as though nothing was correlating with itself. It was where there was a 1, there was a 0. Where there was a 0, there was a 1. I was looking at half and half of the packet because those were logical numbers. It had like an address at the front, and then it would have data in the back. It'd be simple, it'd be like CAN bus. So I'm looking at this thing and I'm going, there's no correlation between any of this. Wait a minute. I remember that. I remember that from RF. That's a sign that you've got an XOR going into your signal. So I took half of the packet and I XOR'd it with the other half of the packet. If you guys don't know, sometimes in transmitting and receiving protocols, they do tricky things like this in order to add randomness to the data, in order to add complexity to the data. Sometimes you need something that is going to make your data a little bit more resilient to interference. In this case, I think VKB was trying to keep us from solving this problem. Overwhelmed by too many tabs? Absolutely not. This is not even this isn't even touching my overwhelming tabs. So an XOR is a knotted OR, which means you have this pattern of 1s and 0s going into it. Where's the, geez, okay, we can look at it like this. A 0 is a 0, a 1 on one end is a 1 on the other end is the 1, and double 1s are a 0. So if you take that and you put that into doubling your signal, you get weird stuff coming out of the other end. And I don't know how it, yeah, the exclusive OR. I don't know how it determines where the 1s and the 0s end up. It's doing something on its end in order to do that. But for us, all we have to do is put it into that XOR. And then I got stubborn. And that was on me. And that's what kind of killed, at least initially killed the project. I knew I'd be coming back to it because mechanically that thing's awesome. But what killed it was my stubbornness and thinking that the sensor was 360 degrees. It is a 180 degree sensor. We were able to get it into the Arduino so that if you plotted the degrees, it was able to symbolize how much this thing had moved, but there was a jump in the middle because it would get to 180 degrees and start at 0. So I was able to decode it all the way to that end, but then we worked on other stuff and it kind of got left by the wayside. But I absolutely adore these pedals. The one thing they don't have is some kind of like a motorcycle. They don't have any way for me to like push them down. Technically, maybe I could use some old pedal hardware and make it so you could push the whole thing down or push the whole thing forward a little bit. I don't know if I want that though, because I've already got my 6 axis of freedom for any game that I would want. What's up, Gonad? How's it going? This is 1 axis. This is 2, 3, 4, 5. And then 6 would be the up down lever. Push them down yet. They don't do that. See, this bearing is locked in. Basically, it's a big plate. It's a big plate over here with a spring, and the plate travels on a bearing, and that stretches the bearing, and the spring moves accordingly. 6x6 axis. I mean, you can use a controller, yeah. You can use this. This is 6 axis. Not as fun. Yeah, they're helicoptery. Toe brakes, I could maybe realize with like something sticking up, maybe, because then I could just pivot. I don't know where these are going to end up though, because the pedals take precedent for now. I just dug this out of a bin. But what we're saying is that I did a whole bunch of reverse engineering to try to break into the protocol that these are talking. I think nowadays, what I'd rather do is just desolder the microcontroller, and then we can throw in one of my RP2040s in there. So we'll have a bunch of disparaged RP2040s sitting around the system, but these some bitches are fast enough that they'll all be able to speak 500 kilobyte per second CAN bus, and they'll be able to communicate on the bus and relay all kinds of signals, and then I'll be able to pull them back and see who's who and what's going on and what for and what not and what have you. Yeah, VKB is the company that makes these. They were really good. I forget what I paid for them, but they were before everything became stupid. So it was a long time ago that I bought them. I guess I could probably lift them up more if I did that, but I like them to go all the way to the floor. Bonk, 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 bonk. Pretty cool. Do we have YouTube on? I think so. I think that's running. We'll wait until somebody jumps in there. Man, we are on the precipice right now of having multiple fast food CEOs doing mukbangs. Like if this escalates, we might have a CEO mukbang. I cannot believe in the future. That's amazing. When is the Wendy's CEO going to pull a Nikocado avocado and gain a massive amount of weight? I missed your inspiring lap setup. Wait, what? Yeah, so the McDonald's CEO did another video. It's like the second one, or maybe this is the first one. I'm so confused about the lifespan of memes these days, but he did a little video where he was like, yeah, this is my lunch and this is the new Arch Burger. We're showing this. They're trying to do like social media, like, hey kids, look at this burger that's too expensive. They were saying, look at this big Arch Burger. And we're talking about it right now, so that kind of plays into their hand a little bit, but he took the SpongeBob like tooth bite of the burger, where he just little tiny bites. And look at that giant arch bite. Neat. And he's in like a sweater vest and stuff. And so today, the Burger King CEO had a shaky video from somebody just recording on their phone that was behind somebody else, but you could clearly see the CEO in his apron. He was perfectly lit. And you know, looking like an Adonis in a CEO apron, and he calls it a burger and he takes a big bite out of it and chews for a little while. That was really good. So I think the next step is to get a CEO to do like a mukbang. I think that is 7 burgers and they eat all of them and then they go, oh my goodness, my belly feels big, for all the fetishists out there. That would be ideal. I hope to see this escalate to the worst. And the worst of it would be pulling an entire Nikocado avocado, who is also a fetishist for eating a bunch of food and acting like a baby. But then he pulled the ultimate hat trick in making enough content for 2 years, disappearing, getting healthy again, because he's been a vegetarian. He's Nikocado avocado. So he's clearly able to get himself back into shape by eating plants. Behold our big chunky CEO. Look at our big fat belly on his CEO. Nom nom nom. Buy our food. It's so expensive now. I can't help it. I have to eat this burger. It's so fucked up. Oh my God, I hope it gets to that. It's just so messed up. Yeah, the only thing that I can do for foot brakes is to like put actual pedals on this thing. Look at all of my CEO money. I'm spending it on my belly. Yeah, okay, sorry. I'll stop doing that. It's so stupid out there these days. It's amazing. As somebody who genuinely enjoys stupid. Yeah, so we're working on the sim setup. I don't have music going on right now just because I played the Mario Odyssey song that had gotten stuck in my head for 3 years, and we're just on to talking about other stuff, so it doesn't really matter all that much. I've unearthed some old sim hardware that is supposed to go along with all of this old sim hardware. So we're gonna have the throttle, the X65F throttle, my favorite throttle, and this has a lot of stuff on it. We're gonna have the VKB pedals. We're gonna have dual joysticks. And I haven't brought it out yet, but I've got an analog up-down that I would like to put probably right here on this thing, which means we just need to redesign the back panel, which I've done before. Each time you think something can't go lower, somebody brings a shovel. Yeah. This is true. Now we're using excavators to get to the bottom. It's true. So yeah, that's just something that I want to work on soon. Basically, we'll do a whole brain takeover of this thing. I don't know if it'll still be Ethernet, but this thing and the pedal could possibly share a bus. That thing's analog. This one's digital. This one has a digital magnet sensor that just has a magnet that twists, because obviously that's what they're translating the motion into, is just a twisty motion, and most of the force being on this bearing and then a pillow bearing at the bottom of this thing. This box is held on by one bolt, and the one bolt is this bolt. No, it's not. It's this bolt. It's very annoying. So I need to get into that and undo it. This whole plate comes off. I had this all taken apart. I put it all back together just to have out. Where's the engineering tape? Which is engineering tape, Hedonica? Which one is that? Engineering tape. I don't know what engineering tape is. You mean the Captain tape is as close as I would think we get to that sort of material. I just had a bunch of noodles, so my glucose level is not going to be kind to me today. At the beginning of the day, what I would like to do is take apart this MIDI pad and just take a look at it, because I've never taken a look inside of that thing before. And then we're going to work on the big boy, the big frame, because for the big frame, I printed some angle adapters. And so those angle adapters will allow me to get the angles right so that everything isn't kind of like trapezoidal on the frame. Because I didn't really spend all that much time like squaring it out. So engineering tape is tape where you tape stuff together and you hope it works. That's just like everyday tape. That's normal tape, right? I don't know. So yeah, remember this is all temporary unless it works, in which case it's permanent. Okay, so that window is back where it needs to be, where I can see chat. My chat window is nowhere to be found. What happened to it? I think I need to Control-Shift-T it back into existence. Let's see how much of a queue I've got. No. There we go, good. All right, that's just gonna be Mario Odyssey. Oh my God, it is. I guess I'll let it play. Of course, I'm gonna get a visual copyright if I put that up there. I've seen it, I've seen that happen before. I had the Prodigy video, one that I really like. I had it up on one of the screens, and I literally had the camera like this, and I was looking up like this, and it got a copyright strike because the video was right there. Ridiculous. I don't know what they do about streams. I don't know if they care, but I'm just not going to approach that visual copyright. The other thing was Mariah Carey, the Christmas song. I had that picture up here from the YouTube video, and that also got dinged for a visual copyright. It's just, there's no bottom floor. There's no bottom floor. It's crazy. They'll get you on anything, man. Bunch of goblins running around hitting you with citations. Craziness. Boop, boop, boo. So I got to do the Raspberry Pi tutorials on this thing, and I got to probably make a wiring harness for the shifter. The shifter, I don't know what it's going to do. If I do have my chair like motorized, go 90 degrees, I could put this as like a helicopter throttle style thing like down here and have that control the seat movement. Maybe, I don't know. But it's got like that display on it because it's meant to be in your field of vision. So I don't know. I don't know what I want to do. A lot of weird stuff I could do with this though. It's just because it's like a 2-position dude. You really only like the video I found, they only used it once. I think you can doot and go directly to drive or something using the button. I don't know. I think the button's just for pulling you out of park. Put you into park, pull you out of park. But I've yet to see this button do anything. Like, it doesn't send a CAN bus signal out. It really should send out a CAN bus signal because no matter what position we put this in, I have been able to get all 4 positions out of it using CAN bus. If we put it in park, and maybe if I maintain the park, maybe then it won't send that, because you got to do that and then hit that to get it out. That's a curiosity, and this thing is not really, it doesn't have any job in my driving system or in my flying system. It has neither have relevance to this part, and yet it still remains the most fascinating piece of card hardware that I've encountered on this project in general. Yeah, there really is nothing more permanent than a temporary fix that works. Hence the tape on the throttle. The gaffer's tape is very sticky, works very nicely, and it covers over the paint scratches on the top here. Although I am going to have to remove it to get to the screws, but it's another one of those temporary, permanent style things. I have to get the CAN bus stuff working because we need to drop into these individual parts and we need to make them into CAN bus things. That's engineering tape. Okay, I get it now. You know Beam Drive? I'm going to end up doing Beam Drive. Yes, I'm going to end up knowing Beam Drive by the end of all things. I want to get the driving simulator up to a certain point, and to where we can actually play games with it. There's a lot of hurdles that we got to get over on our way there. This is a big project, and it doesn't happen overnight. It's going to happen piecemeal, little bit by little bit. Our next thing to do is to vet out the CAN bus. If I can actually use the CAN bus in the way that I want to. I know it's going to use CAN bus because everything uses it anyway, and it's fast enough, right? But I need to know if my schema, if my little connect the dots idea is going to actually work. And so I need to get this Raspberry Pi speaking CAN bus on Node-RED and evaluate how fast it is. And in the meantime, while I'm doing that, if I set up to have sort of a generic controller type, like a CAN bus accessory that speaks our particular schema, then we can start putting it into all of this hardware and interconnecting all the hardware to see if we run into slowness over here. Which makes, that's also temporary, that's also engineering tape. That's sort of the methodology here. They will eventually speak CAN bus. It's just whether or not the Raspberry Pi with the CAN hat and Node-RED are going to be fast enough, because this allows me to kind of scale and modify the setup on the fly. It'll allow me to do things quicker than if I didn't have a little point and click interface on it. Obviously, I could get it working. I could use one of the sort of the bruiser microcontrollers that I have. The TC4 would be 4.2. No, just TC4, I think it is. I could use the TC 4.2 too, but TC4, way more than enough computing chops. That thing is like 600 megahertz, like faster than my computer. And then I could put in like an XML file or something like that that would describe what's connected to what. That would, so then changing it would require me taking an SD card out, putting it into a real machine, opening it up in like Notepad, and then reconfiguring what's connected where. I don't necessarily want to do that, you know? Would you say the Space Mouse was worth it for Fusion? I am on the fence about that. This is a nice mouse. This is a strange accessory. A lot of people who use CAD love these things to death. And they're pretty configurable. This thing was great in Kerbal Space Program because then you could run around in the builder and make sure that you're attaching struts exactly where you want to attach them. In Fusion, it does the same, but then again, I've got all these buttons right here. All I need to do is hold down Control and move the mouse and center click and do stuff like that. With this, I don't have all those buttons in front of me, although I kind of still do because they're right there still. So it may just be a skill issue on my part. I bought one many years ago, and it has been sitting in collecting dust for a very long time. And then 3D Connection said, hey, can we send you this $100 thing with both of our devices? I said, yeah, I'll try out the mouse. And I got both of them in the mail. This is cool, it's Bluetooth. So maybe if I was on a laptop and I was using Fusion, I would appreciate this kind of thing in order to just have slightly better control of everything moving around and what I'm looking at precisely. But again, I don't find myself reaching for it. I like it a lot, but yeah, I don't find myself reaching for it. I'm keeping it close by just in case I find an application where I absolutely need to have that 6-axis of freedom, because you can really do a lot with that. And if I'm using something like Blender, this is probably really, really effective in something like Blender, where the camera is a little bit more open source. Should I put it gently and say open source? Because then you're in control of exactly where the camera's sitting, instead of using like the Fusion says, oh, I think you're looking at this, so I'm going to revolve you around that point. This, you could just say, I'm going to move that point. Those are my thoughts. I wanted to know what this part was, not this. What this part was that I found in a drawer. I don't know how powerful this thing is, but it looks like some kind of a photoreceptor. But it's got like threads. There's threads and then a shiny thing at the back of it. BCF 994 9A17. BCF 994 9A17. Cool. Did I get it wrong? Probably got it wrong. I don't think it's a laser diode. 994 9A17. Yeah, I got it right. It is the right form factor for a laser diode, but I think it might be a photoreceptor. All four of those are insulated too. And that looks like a solar panel kind of thing. It doesn't look like a typical lens assembly. Oh, wait, is there a convention on that? BC? I can't believe there's just nothing. Data sheet. BRF? Probably not. Not even close. BRF 949. No, it's just grasping at straws. Get rid of the 9A17. NXP Semi. Oh, that's not the right part, but depletion type FET. Yeah, I don't think we're going to find it. See, this is BF, not BCF. Many transistors start with a B. What's up, B? Photoreceptor transistor threaded. Damn it. This is an obscure search, huh? I don't know. I don't know what it is. Photo detector, maybe? I mean, it's got, I don't understand where did it go? I don't understand why this thread's on the front of it. This could have been recovered from a research lab, and the research lab was doing study about brain imaging using optics. So this very well may be an optical part where some kind of a fiber optic is supposed to screw into the front. But the part number is certainly too obscure, and I don't think I can get it out of this. Yeah, it's like pressed in. So, and the fact that it's got like a piece of aluminum on it that's opaque, well, transparent aluminum, we're not in Star Trek, so I do have a parts tester. I could maybe give it a go on that. Let's see what it says. Because I don't know, 4 leads. I don't know what the 4 leads are going to be. One, two, three, 1, 2, 3, or 1, 2, 1, 2. Yeesh. It's not really made for this pinout, huh? Can't get to a 1 if I do the 3, 2 there. 1, 2 there. And then if I go... this isn't going to work. This isn't going to work. It's going to come up with something weird. Was that? That's not. No, that was open. Just hard to navigate these little weird pins. Well, it's definitely not a capacitor. It's some kind of a transistory thing, but I think it's a little bit more hardcore, science-y. 1, 2. I gotta go like sideways with it. That's not gonna come up with anything. It's just gonna say it's damaged. It like blasts a laser beam at me. It's a resistor. I don't think it's a photoresistor. It says it's 50K. No, the pinout is very strange. It's got definitely 4 pins. How do I turn this thing off again? There you go. Hold down one of the buttons. Yeah, so 4 insulated leads. And then I only have one of these. I don't know how much, I don't know the cost or something like this, or if I've ruined it by getting light in there, by getting dust in it. It was sitting in the bin that had the VKB pedals in it. I mean, it speaks to me as being just a piece of silicon that's been exposed to whatever's on the end of this barrel. Hey, Incredimike! Thank you for subbing for 18 months. Whoa, and Wonky Robot. Hello, world. Hello, Wonky Robot. Good to hear from you. Yeah, thank you for subbing. Hey, I really appreciate that, you guys. We're looking at a weird component that I just don't know what it is. It's just the intro to the stream. Something that I dug out of a box, and the box happened to have my VKB pedals in it. VKB pedals are these things. Hold on, I gotta, nope, I gotta put a foot down. There we go. These are the VKB pedals. These are something that I famously reverse engineered from the brink of existence. Nowadays, we're just going to make it into a CAN device, but these sit on the floor and you use them as foot pedals, and they kind of do the helicopter-y foot pedal thing, right? With no toe brakes. There's no toe brakes on this one. I maybe could put another pedal at the front of these. I don't know. But these will definitely find their way into the sim setup somewhere. But at the bottom of that box is this weird component. I don't know what it is, and I'm thinking it's a photoresistor. Hit it with a hammer, maybe. All bets are off. I don't know. I don't know what it could be. It could be a photodiode of some kind. I'm thinking probably photodiode because of the potential origins of this thing. But it is a fascinating little piece of technology from yesteryear. So we were taking a look at it. I'm going to put it away. It's possible, like if I treat it like a photodiode, I could maybe figure out what the leads are and then hit it with some light and see if it opens up or not. Because it could be just like a very sensitive light detector. But there's no data sheet. I can't find a data sheet for the part number. I looked everywhere. As in that was my stream exploding. I'm trying to find a drawer that I put this thing in. Where would I have put? I guess here. Oh, I still have this. This is the magnet sensor from the brake pedal. This is what turns on and off the brake lights. This thing is just a little magnetic, it's just a little not Hall effect, it's just a little magnet sensor that you can adjust the depth of. I don't know if this is gonna make it into the sim setup. I don't think it is. We're gonna be rolling around on the floor today, trying to install stuff. I'm gonna get start soon out of here. There it is. There's the button I'm looking for. How's everybody doing? Welcome to Oh Bother. Quiet day today, huh? It's just raining outside here in Philly. Cold rain. I've got 2 dogs upstairs and I've got 2 people upstairs. So there may be noise in the background, especially if somebody decides to, I don't know, like deliver a package, which happens all the time. The 2 corgis have sort of a feedback loop off of each other, and they sort of cascade out of control, which was my entire major in college, read motors and controls systems and stuff like that. Which was cool, but there was a lot of math. So if I need to, I may need to find the eigenvalues of my corgis and figure out how to keep them from feedback looping. They're fine. They're just going to be barking at the door. So could the sim setup control the synth setup? I could make them all in one, and then I put on goggles and I sit in the chair and I've got the speakers facing right at me. Wire this up to this, we get this joystick over here, and oh my God, it's I don't know, man. I think I'm gonna keep those 2 separate because the synth setup is something that I may take to Julian's house if it works at all. I haven't been able to do anything like cool with the synth setup. Maybe I need to buy filters or something. You know, we'll get back to doing music stuff. I just kind of put it on the back burner until the responsibility of this BMW seat kind of comes to fruition. That's what I was looking for. Because I need to do something. All this sim hardware has been sitting in the wings since I've been streaming. And I built the steering wheel setup here. This out of the way. I built a steering wheel setup that relied on clamps to clamp to the side of my desk, right? But that's like, when are you going to use that? I have to say like, oh, we're going to do a game stream, and I'm going to get the 20-pound motor out, and I'm going to clamp it to the side of my desk, and then we'll set up the cameras and blah, 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 blah. Well, inevitably that leads to the thing collecting dust, which is what I was just wiping off. Collecting a ton of dust, not really getting used, sitting in the wings with all the other sim setup stuff. And so my brother contacts me and he says he's got a BMW interior that he doesn't really know what to do with. It's like, well, I'll take one of the seats as like a permanent holiday gift, because I don't want you to buy me weird stuff. I want you to provide me with weird hardware that I can use. So now I've built this piece of furniture in my shop, where all of my sim hardware is going to essentially be attached. And we've got to kind of bring that all together. And me being me, I have to have it be some kind of a hacky thing and do something shocking and interesting with all this hardware that I have. So I sourced a bunch of rails. We cut them out here. You guys saw how many chips those produce. It almost seems like milling them on the milling machine, although incredibly involved and time consuming, keeps all the chips in the milling machine. It doesn't throw chips literally everywhere in the shop. I'm still finding chips. I don't know if I can make like a cardboard box that goes around that chop saw, but as soon as you move the chop saw, it pukes chips everywhere. It's insanely frustrating. So anyway, we got the chair mounted. That's easy. Wheels on the legs, that's easy. The steering angle and the pedal angle were both weird ones. I bought a steering column from a Mercedes-Benz, I think S-Class. The steering column from the Mercedes-Benz, being that it is a luxury car, is incredibly long. It is a huge piece of hardware, and it was only 20 bucks. It was like $60 considering shipping, but it's like 20 bucks for an entire steering column for a car. Cool thing about that is I got all this U-joint hardware that's supposed to attach, you know, all of your steering connections together. Woo! So maybe these could become useful later. You can see this is built out of thin aluminum, and it's got like a heat shield on it for the exhaust to go by, but it is made out of kind of a flimsy pipe with these little nubbins on the ends, right? This is not for lightning suppression. What this is there for is so that it can collapse. Because when a car gets into a car accident, all kinds of shit gets crunched, right? And you need to not crunch the human. Turns out we can crunch the human. We're not getting into an accident with this thing, at least not physically yet. So what I was able to do is actually squish that steering column by crashing it, which is kind of insane. We looked at all the crash structures that existed on that. Pretty cool. I still need to put the 20-pound motor that's sitting right there. You guys can't see it. The 20-pound motor on the end of that and allow it to also adjust at the same time. Mercedes did this weird hat trick with their steering column, which is this right here, where it can actually extend. It can extend and contract. Insane. The thing that's vexing me the most right now is that in putting that big frame together, the angles were supposed to be particular weird angles. Yeah, sim racing crumple zones, exactly. They're supposed to be like particular angles, like this whole setup is built to kind of display that. Actually, it's this, like this. So the steering column is at one particular angle. Oh wait, actually I need all three of them. Hold on. For those pedals to be at the right position, I need this particular angle right here for them. Otherwise, they'll be sticking out too far and they won't feel right, or they'll be sticking too far in and they won't feel right again. So I did a lot of measuring. I did a lot of dead reckoning, to be honest. It's not as accurate as I think I'm making it out to be. But these were the angles that we discovered in CAD after scanning everything. So steering angle here. This is 90 degrees, like everything wants to be. And then this is the angle for the, actually, I think it's the other way around. Hold on. This goes here. Because it's a slight angle for the pedals. It's not that hard of an angle. Hold on. This is how it's supposed to be. Yeah, it's more like it. So yeah, 90 degrees, pedals, steering column, because the steering column is not flat on, you know, luxury car. It's got a little bit of an angle to it. And then from there, the reason I bought this steering column is that it's adjustable. I want everything to be adjustable on this, because that would be really funny if chat was able to actually go in and adjust things and start moving things around. No numbers in parts with a part plan. I don't know what that means. The language doesn't, what? Planned parts? Anyway, so I spent my weekend designing these. Now, they're not that complicated, but our 3D model of the pipe, the 3D model of the bars is not the same as the actual bars, so I had to do some trickery in Fusion 360, and my printer is not really good at these kinds of angles, so these are kind of rough. The only purpose for these, though, is so that I have a piece that slots into the rail and then puts a flat section at the right angle. That's the only purpose of these. Well, actually, the secondary purchase is if I trip and fall on the simulator setup, I don't cut myself on some of the sharp edges. So having a plastic moderator between the things is good. And then on the outside of this, there will be an aluminum bracket, which all the force is supposed to go through the aluminum bracket, not this part. This part is there so that I can just butt it up against each other and say, okay, yeah, that's at the right angle. So in before chat keeps setting the seat forward. Basically, it'll be like a cat and mouse kind of thing where if it starts moving, I'll reach for the controls and stop it and then move back into position if I have time or if I'm not currently crashing the car. But we can weave that into other facets of this too. One of the things that I need to do that's intimidating that I haven't looked into fully yet is OpenFFB board is likely what we should be using to control this whole thing. OpenFFB board is a very popular force feedback control system. You can do feedback joysticks and all kinds of, wheels and stuff like that. So we're just going to be using it for the wheels. It's the only accessory that I want force feedback on. Having it on the joysticks would be nice, but that's a whole nother can of worms. I probably have the motors for it too, for the burn the subs. But anyway, OpenFFB board, I need to put that on the Granite Devices board that I have. And I think there are people that have done that. I think people have done that before. So I've got to just kind of put the two together. Before I start rolling around on the ground in order to install these angle bars, I want to take a look inside one of my other accessories that is actually for, not for this, well, it is going to be in the sim setup because I'm going to have buttons and switches and stuff all over the place and control panels and things like that. Physical switches are really fun. And I would like to have something on the right side and maybe something down on the left so that I can click, gets all the buttons and stuff. So doing that, I can use some of these old accessories that I have. This is a cheap MIDI pad. And they say it's MIDI, but it plugs in with USB. So I guess it just interfaces with things like Ableton and such like that. It is actually a joystick when you plug it into USB. And so I was able to get it working with like Star Citizen. And I had this for turning on and off like interior lights and stuff like that in Star Citizen. Pretty cool. It's broken. The USB was one of those hateful USB micro or mini or micro, the bigger one. USB micro is fraught with disaster, even more so than mini. Mini is like kind of okay, but sometimes they don't solder it correctly and it just pops off the board. Micro, inherently, when the pins are plugging in and you need one thing to ramp on the other, the one piece of it sometimes gets pushed back, and so it's got a little like a piece of the pin there, and it gets pushed back like that, and then it ends up hitting the outside of the USB plug, which is grounded. And so you can instantly short out your USB minis. They were okay, it's just they eventually get loose. Like we're plagued with a USB mini on this thing, and it is so annoying because if I move this camera at all, it can tend to unplug that plug. We were going to put a USB-C there though, and that was when we discovered that my mill's X-axis is still broken. That mill we need to tear down to its bones, but we've got enough projects ahead of that. So yeah, I want to pull this thing apart. I want to talk to Samson. Fly to the moon and back. Let's see. Yeah, so I just had two things of the 3M dual lock to attach that. The cool thing about this is that it's exactly the size of a 10 keyless keyboard. So this is a pretty snazzy setup right here, either with the 10 keyless or with this weird truncated thing that I have, my weirdo Drivo. But yeah, you can make a whole setup using this and have your little crossfader and your MIDI things and your keyboard above it. So it's a pretty neat little, yeah, USB micro is the devil. It is indeed. But anyway, this has evolved over centuries of collecting stuff. I'm going to finally finish this thing and then I'll die. I'll finally be dead. Anyway, I want to take a look at inside of this MIDI thing to see what's involved in it. Obviously, I could just buy another one. I don't know how much they cost these days. But if this one's already broken, that's kind of a godsend because we're turning everything into CAN bus. I was thinking that, you know, the Raspberry Pi, it has USB slots on it. I could just plug some USB stuff directly into the Pi and use it in Node-RED. But if I don't have to, I won't, because there's only so many USB slots on that thing. This will be my pyramid, yeah. just have an archer hit me with that flaming arrow and then throw this thing off a cliff with me in it. The whole sim setup. And then I'll land at the bottom and be like, oh, it's fine. It's these rails are too strong. My Node-RED has a data arriving via USB. So this could actually, well, the plug on this thing is broken, so it's good that it's broken. That way I can get in here with my little perverted hands and take it over with a microcontroller. Even though there's probably a microcontroller powerful enough on this thing already that I can take over. Hey, Code Rush, what's up? Sorry, I'm talking about my perverted little hands. I apologize for doing that right on the precipice of a raid. We're gonna do some physical stuff with the sim setup and get my rails to be at the right angles. I have an Arduino plugged in with sensors all attached to it, so I can do 5-volt stuff. Interesting. That sounds neat. Maybe I could justify keeping my DJ controller on my desk if I assigned a bunch of regular computer stuff to it. Joy2Key is one of the more famous ones. Joy2Key, and then I use FreePi, but that was back in the day. Gonad probably knows some better stuff for using that kind of stuff. But yeah, you can totally reassign it and stuff with all these modern programs that they have. The FreePi was the one that I used that sort of let you program it like it was Python, and a lot of people used it to make their Wiimotes do stuff on the computer. But that was a long time ago. 84 years. But yeah, we're working on the Simpit a little bit, and then I'm gonna work on the Simpit a little bit more by getting down on the floor with it. That's gonna, I'm already sweating because this house is hot, so I lowered the temperature last night. They've discovered it. They've already discovered it, and they've raised the temperature again. So now I'm sweating. They go, oh, it's so cold. Let me just turn up the heat. Like, we can't afford that. I use FreePi to convert my head tracker to mouse movements. Yeah, FreePi is a good one. Okay, so they didn't do anything with the back panel. And then we have, I guess, yeah, those are just caps. Caps and resistors. And then we have a microcontroller over here. And then there's a lot of screws to hold this thing onto the buttons. Oh, and there goes the USB plug. This is the plug. It's the USB plug. What up, Wiggleheimer? Yep, there it is. There's the plug. The plug that failed me. Hopefully it didn't take anything out with it. See how those pins are facing this metal shroud at the back? And the metal shroud's even pushed away from it because of the damage that was done. USB micro was a lot of lessons learned in terms of mechanical. Because you've got, I mean, geez, did they not figure that people are people and they're going to put 10,000 pounds of force onto these things? They just decided to go with whatever. So where did that attach? That was somewhere around here. Yeah, there we go. There's the landing pad. Well, let's get the whole thing taken apart. Let's get the other piece off so we can actually take a good look at it. Micro's half the size of Mini in 2 dimensions and still stronger. Well, if companies had honored the through-hole placement that was supposed to go around the pads, they would be a lot stronger too. This one ripped directly off of the pads. It would have behooved them to have a via nearby. Like on the big ones, on the big mechanical ones, have a via on it so it forms like a solder rivet. Because that'd really hold it. It's the solder, it's not the solder that's broken, it's the strength of the pads directly down onto the fiberglass that's ripping up. Mahalo went way out of their way and they sent me this electric screwdriver, and yet I insist on sitting here and using the physical one because it'll take me 2 seconds to put together the electric screwdriver, but it'll take me even longer to manually unscrew these. I should look up stubborn in the dictionary. USB-C was an overall improvement on both formats just because of the reversible nature of the thing. And if you actually follow instructions like the standardization, then you should be putting together a pretty strong connector, and then you actually have to solder it to the board properly, or else it then will also have the same fate as all these other plugs do, which is ripping off of the board and taking some of your traces with them. I also want to blink light in Star Citizen. This was from Amazon, and I don't remember what I paid. I don't think I spent a lot of money on this, but I think it is a lot of money now. I'm not sure. But yeah, it was kind of really cool for Star Citizen, like cabin lights and stuff like that. I had to label them. And then I don't know what I can do nowadays. I haven't looked at Star Citizen in a little while. There's this whole programming thing on it, and there's all kinds of other stuff you can do with it. But if I make this into a CAN bus accessory, I think I'll have a lot of... You have one click too much, and no one uses your product. What? Internet designers are right. It's all about those micro steps. I suppose so, yeah. Okay, all that stuff goes over here. Oops, I gotta be careful with these controls that dropped off. Yeah, any MIDI controller would work. They're all compatible. This one just showed up as, I think it shows up as a joystick with buttons, so I was able to just I was able to just mess with it. But yeah, they're just simple pads. And if I can get these on CAN bus, then I can do anything I want with it. Yeah, USB MIDI is what this was. Let's look at the damage. It's a lot of damage. LM1117, 1117. We've got audio people designing these things. They're using audio parts. And there's the USB, and it's just very simple. That will be replaced. So if we've got the 1117 there, that means we can go up to 12 volts on the input voltage, which is pretty cool. I don't know. Interfacing with USB, I don't know the ins and outs of it. I could interface this to the Raspberry Pi with USB. They even give us a JTAG port. Look at that, JTAG right there. I don't know what you are. And then everything else is computer, and it's an ARM. Wait a minute, STM32? What, huh? Oh, I could just reprogram this myself. The Pi should do USB MIDI, no problem. Yeah, it probably does. Wait, that's just straight up an STM32. If I was better at programming STM32, I would maybe want to take it over. Push comes to shove, I desolder this and I put in my own thing. It would probably have to be some kind of a port expander, and then I would have to see about... It looks like it's probably doing a row column thing. Yeah, because of this stuff out here. The resistors and capacitor filters out on these guys. I know, the JTAG's just right there. Right there for the exploitation. I wonder if anybody's hacked these things before. Because like when I had it plugged in as a MIDI thing, I wasn't able to like control the LEDs. That's kind of the thing that I'm thinking about for this, is like, if I want, I can display other stuff on this using the LED pins. A 7400 series, 74HC405 CD. I can't believe it has a 7400 series. (74HC405). It's probably a counting interface. Mux demux. Okay, that makes sense. They ran out of pins on their STM. Didn't we use one of these the other day? Oh my God, so many specific temp ranges. So 4051, is that a 1? Yeah, 4051. So we've got a mux going on over here. Who is counting my mux? Oh, we're muxing these guys into an analog pin, I think. Do 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 do. That song is just forever stuck in my head. Yeah, I think we're muxing our analog pins. So we've got the HC 4051, which has, it's got a 3-pin address select, although it looks like they're using 2, because I think 2 and 1 return. Where's the, let's see, VCC is on pin 16, channel in out, channel in out. Pins 1 and 2 are actually the channel out, so they're going in this direction. Huh, wonder how they're doing this. I have composite video running through one of those 4051 chips. Neat. What up, Poopsie Doodle? I have those on my bench. Yeah, these are the like, nice little surface mount ones too. The most versatile MIDI libraries for the Arduino Pro Micro. Really? Yeah, nice little remote switch. I think, okay, so we're coming from the center pin of all these, and one pin of all these, is it connected to ground? Doesn't look like it. Let's see a ground connection. Because these aren't encoders, these are just potentiometers. Oh, they've got their own little supply going to it. Do it to it. Yeah, their own little tuned voltage divider. So let's see, the outputs are coming from pins 1 and 2, and the notch is right, I think it's on this side. Be these two here, but those seem to go this way. So there's probably, I don't know, I'm just not, I'm not tracing it very accurately. What was that through hole? Oh, it's a capacitor. There's no LEDs around these. Okay. Yeah, okay, so the STM32 is muxing to its analogs. I wonder what's going on over here. So over here we have the probably feeding directly in, because you've got this is an encoder. So you've got an encoder, you have one analog here, and then you have 6 over here. This thing is a 4-pin device, or 4 to what? Channel A and channel B. Oh, wait a minute. No. This is a channel in and out, A2, A1, A0, A3, A4, 5, 6. Common out in on pin 3. Yeah, 8 to 1 or 1 to 8. So that would be 6, 7. I'm counting numbers. And the youths, those precocious bunch, have chosen their meme to be 2 consecutive numbers, which means when you're counting 1 to 10, you inevitably stumble across their meme. I think it's unfair of them to have done this. For my generation, we had 69. Although still common, it is a 2-digit number. It is not simply counting 1-digit numbers next to each other. It is a 2-digit number. It still shows up all the time. And you can see to the reaction that is typical. 6, 7 are 2 numbers in sequence. It is not fair. 42, yeah. They're not directly next to each other. So I am not memeing. I am simply counting things. Now, the question I have is, does this go all the way back to the mux, or does it have its own analog? just for curiosity's sake. So we have our fader is what pins? What pins are you? You are these over here. What is this stuff all around? It's got like heat sink stuff. Weird. So we're measuring the ground. Whatever this is. What is that? Wow, that is a supply line, I believe. Just because it's branching off into so many places, I'm making an assumption that this is a supply. Is that a working MIDI controller? Yes. Well, yes-ish. Yes-ish. It seems like I could bring this back to yes if I resoldered those properly. This is a Samsung. Samsung. Samsung Graphite MD13. It's a little old, but it's really good. I really like it for having a lot of buttons that I can hit. It's got a lot of buttons and it's got little lights behind the buttons, and I would like to directly control those, although STM32 kind of kills me. Chatang. You can create new signals with an open source lightweight software platform called Chatang. Chatang. Cool, but I don't know if I'm going to do that. I would much rather throw my own microcontroller on here. ARM, I've done very little programming with ARM, and it seems a little needlessly complicated for me when I'm just like this plucky little Arduino programmer. So if I could drop an Arduino in here, and obviously can take over the 7.4 4051 as, you know, the remote analog switch. I don't know if there's an analog running all the way to the fader though. That's what I was looking at. So all the way out here with the fader, we've got power, something else, 2 pins there. There's our signal coming out of it, going through C9 all the way back, and under, and under, and under, and oh, there it is. I see it is poked out just a little bit right there. Continuing on to the via, the via that leads under the 74 HC 4051. So yeah, this thing is muxing all of the analogs, all of them. Great tool for taking any kind of input and creating any kind of output. Like these buttons light up when you push them, but I want them to do more. If I have something that's like a lighting control, what I want to be able to do is have it speak CAN bus, and I'm sure the STM32 that's in this thing already, I could just reconfigure to speak CAN bus. I'm sure that's a thing that engineers know how to do, but I'm dumb. You guys give me all this credit for being way smarter than I actually am. I know how to program Arduinos. I would rather this thing speak Arduino than anything else. But STM32 programming kind of intimidates me. I did a little bit of it for the modular synthesizer stuff. Maybe I could go back to it. Might respond to incoming MIDI to light them up too. Might. I'd rather geez, you guys, I'd rather take this thing over so that I have direct control of all this stuff. So if I push the button, I can have it light up or not. I can have it toggle the light on or off. The lights on the controller take MIDI, not signal. Not for long. Not for long. Not if I have anything to do with it, because it is just an STM32. It's just an ARM chip. I know a little bit about ArtNet, but not much. I've used ArtNet. STM32F103. Just for... Arduino. Some weird-ass project. STM32 Blue Pill with Arduino IDE. 32F103. 32F103. Well, maybe we could Arduinoize this thing, and then I could throw One of these guys. Hold on, let me find it. It's buried. The thing is buried. I don't know where it is. Okay. Throw one of these on it and have it speak CAN directly. I spent ages trying to program those little blue bastards. It's possible. That's not a ringing endorsement. Are these things STMs? Oh, no, that's an RP2040. What about you? No, you're kind of an ESP, like a giant ESP thing. ESP32. I don't know what brain's in it. There's a brain under there. What else? I had another one of those weirdo boards that I bought for like not that much money, but it's also just sat since I bought it. This would be the default brain if everything doesn't work out with the Raspberry Pi. We'd be going to this. This thing can do your homework. This thing is like 600. This thing is like gigahertz. This thing is faster than my computer. So it could eat my dog. Don't allow microcontrollers to eat your dog. Don't do it. Don't let it happen. It could happen to you. Cortex M3. Okay, now we're starting to use weird words to describe what all this stuff is. I don't understand all these words. So anyway, the point is, like, okay, STM32, if I could actually get that to speak Arduino IDE, then I wouldn't be so intimidated about programming it. I could also get in with that JTAG plug, or maybe just with USB. If I repair this board, I could find any pins that might be left over, although I don't think there are, and I could make those manage CAN bus. Yeah, it's M3 like the car. It's ARM Cortex, but it's a sports car. I wonder if their lawyers all get together, like whoever's in charge of screws, like the screw lawyer, and then the car lawyer, and then the ARM lawyer, the STM or Cortex lawyer. Cortex lawyer sounds like an evil cyberpunk thing, and they all just get together and bang heads for a little while. You copied me. No, you copied me. No, you copied me. But really, just like 6.7, it's just M and then a number, and it really shouldn't make your brand iconic. Okay, that's fascinating, the fact that this is an STM32. With any luck, I might be able to plug into JTAG, burn a bootloader onto it, and then program it like it's an Arduino, which is much, much easier for me. That's so much easier for me. And that means I would have direct control over the button matrix and the mux for the analogs, and then the encoder and the LEDs for the buttons, which may also be part of the matrix, but that means that we have to do keyboard style reverse engineering on the thing. Time to trademark the alphabet, yeah. So someone went ew, and they were like, no, this is M3. Oh, because they mirrored it. Somebody was looking in the rearview mirror and they said, what if we called this disgusting car? Blue Pill is not internet incel speak. It's a feature-rich development board based on the STM. I feel like I've had one of these before. STM32 103 CT86 processor, 32-bit ARM controller, 72 megahertz frequency. Unlike the common Arduino board, which is easy to use, program the STM32 Blue Pill it's shit. It's so bad. It's so bad. I hate those guys. STM32 eat my whole ass. I don't know why they're like that and why Mutable Instruments decided to use them. And it seems like maybe some engineers make the decision to use these fucking things just to piss the rest of us off. It seems like that. I have one in one of my drawers. I hate you. I hate you. I don't like you. Because these are so ass. I had to run like my own environment and stuff in order to get this thing to program for the Mutable Instruments ones. Are they French? I don't know. RBT something or other. STM32F103 is fairly common in powerful systems. I think this is a little too powerful for a MIDI controller. Hides all of my Nucleo boards. I hate them, and I hate you for liking them. 6 processor, 32-bit ARM Cortex M3. They are very powerful. They're very nice microcontrollers. ST Microelectronics probably makes these. Is fresh, cream frish, French and Italian. Okay, sorry, I had to, that was a typo that completely destroyed my ability to read languages. There's several ways to program the blue pill with Arduino IDE. Some require external hardware. Others need a USB cable. The following guide will cover 3 common methods of downloading the sketch in Arduino IDE. Arduino HID bootloader, ST-Link emulator and programmer. That is this thing right here. Whenever this thing gets use, it is a cursed day of confused oh bother. The ST-Link emulator. Pennies on the other side. The other side. Okay, the other side is correct. This is the correct. This thing is a pain in my butt. Hooking it up is always nerve-wracking. Using it is always nerve-wracking. It is possible that you can program things with this, but man, if you can do it any other way, I would suggest it. These are cheap. The real ones are a couple $100, so those are pretty much your like, it's too much information. Those are your like default programmers and stuff. I have 4 of those. They seem to have a random pinout each time I get them. That's, I think, what my note is all about, is that the pinout, because they put like 2 pinouts on this thing. One of them is wrong. I would assume this one. This one is the correct pinout. Absolutely nightmare inducing. Just the worst. So yeah, we eventually got this one to work for the synthesizer stuff. So if I need to, I could go to that, but I don't really want to. The other way is a USB to TTL adapter. We have plenty of those too, but going in via USB will not be that much of an issue, in spite of the fact that that's on the other side. Yoink. In spite of the fact that USB has left the building, I could probably solder a few jumper leads on there, because I don't know if, I hope we do have the extra pinouts for running CAN bus, because the STM32 can absolutely run CAN bus. Even if it does have sort of the dumpy Arduino IDE attached to it, it should be able to still run it. So I should be able to connect this, and then all of my lights are separate from all of my analogs, which are separate from all of my buttons. So this would be a button in a packet. This would be an analog in a separate packet, an encoder tick in a separate packet, and then I can light these up when I want to. That would be ideal. And again, this is just theory crafting. This is too much of a project right now. I just know, what's up, Dove Love Loft? Sorry, I'm a little late in getting to you. We're theory crafting right now. We're just coming up with things I might do in the future. Is this possible? Is that possible? We discovered that a hard takeover of this lovely device is impossible. We can't do a hard takeover, I'm sorry. We can't desolder your microcontroller and give you a new brain, a brain that I would be able to more easily get into, because we discovered that you've got a pretty capable brain already, and we're going to use that and just reprogram it. I'm just going to of course, redo the programming on it. And if, well, when push comes to shove, and I might just do like, put a piece of tape on the back here and just write it down with a marker. I'm gonna have to figure out what the pinout is. I'm gonna have to reinvent what the pinout is and figure out what the matrix of the keypad is. Now, it seems like they bought the whole microcontroller, so they're gonna use the whole microcontroller. So I think the one big struggle would be finding 2 pins that'll do TX and RX. Although we can just take JTAG TX and RX. We could just take them off of the JTAG plug if they're not doing something else with it. Because yeah, keypads are very pin heavy, and it really does look like they are using them all. Wow, that is a lot. That's a lot. It's a lot. It's a lot. None of you guys know that song. Why would I sing that? None of you know this. You don't know that. You don't know that song. It's a lot. It's a lot. It's a lot of life. And then it's like a tech house song that none of you know, and yet I'm singing it as if I'm talking to like Julian or John, my IRL friends who know all of these weird freaking references that come out of my brain. You guys just don't know. F, yeah. Streamer existential crash out. Stream over. Oh, notice the Philly accent coming in there. That's that Philly in me. Over. Over. Let's go over to the shore. Want to go to Wawa and get a hoagie? It's over. Oh my God, that really bugs me. Ah, what the? What are you? I can't do it, chat. I can't do it. Oh, it's so bad. Is it my network or are you dropping stream off? And let's take a look at my bitrate. Bitrate says we're in my typical zone. Never heard it. It's some tech house song. It's something that a friend of mine would always mix into his big mixes. Frames drop, not just you. That's weird. I'm on Fios, which is typically really, really strong. It is a rainy day. Up north, it's a little bit more icy, but I don't think weather's factoring in too hard. It's fine, you're sharing the good stuff. What? Yeah, it's 52 something or other. Oh, I don't know. So yeah, we're just shooting the breeze on this one, right? I think what I can do is take this over using a tutorial like this. So additional board manager, that'll add that hardware. And then maybe I can plug it in using USB. Arduino Uno, STM32 boards, generic FTM32F1. And then you choose, I would probably be a generic F103. Let's see, what are we, C1, C2, Z, whatever? Shit, we could do this today instead of rolling around on the floor. 103RB, R8, R8? That's a B. That's definitely a B. That's a flat line right there. R4, R6, R8. I'm hoping that's RA and RB. The rain's confusing the ones and zeros that are flying through the air. Let's see if this is going to fit back into its enclosure once we're done our evil deeds. We'll use a right angle, really, the hangulation of the angle. Am I really going to talk like that? I am not AVE. I'm not a crazy person. I am not AVE, and I will not talk like AVE. In spite of the fact that I used to watch AVE until he went crazy, or until he outed himself as being crazy as a northern... He's not a northern Canadian. He's an oil Canadian or something. I don't know. Everyone should have seen the writing on the wall on that one. But I think he still has his fans, and I still think he talks all weird. And if you really want to cringe, like to the point where you cease to exist, you cringe so hard that you form a black hole and get sucked into it, ceasing to exist, you should check out his subreddit. It's pretty funny. Everybody's trying to sound like AVE. So the thing about using a right angle header on the JTAG pin is that I could also make that where this plugs in. If our JTAG pins are being used just for programming, we could flip their functionality over to doing CAN bus. And so I would plug in a little board that would interface these two, and then this thing can exist inside of the enclosure. Maybe. Maybe. That, or I plug it in with USB, which requires soldering, because otherwise the USB, I think it'll go directly in. It goes under this. Those are its resistors. One of them goes to another thing, like a filter. The other one goes there. That goes up and over and straight into the STM32. Yep. So if I do JTAG only, I could also make the USB pins into my TXRX. Same happened to me with Ben Heck. Did Ben Heck go crazy? Because Ben Heck was super smart. I liked Ben Heck's content a lot. Well, I'd only ever experienced them through like reverse engineering LCD connections and stuff like that. Like he knew the old magic. Headers. We'll start with headers. Head doors. I'm looking for the bin full of headers. It's right over here. There we go. Stream froze. Oh man, am I becoming Sark? I was watching Sark last night, and he was having all kinds of. This is a beard hair, by the way. It's not a. That's not. It's a beard. That's a beard hair. That's a hair from my beard. Hair from my beard. I was trying to watch Sark last night, but because of his strange issues with internet, it was a very difficult thing to watch. Had to keep refreshing the stream. So if I lock up, I have no indicator on my part of it happening. My bitrate seems to be good. I'm in the upper fives. It jumps a lot. Bother may double check your stream health. I've been looking at it this whole time, man. OBS is recording dropped frames. Why are you dropping frames? The computer appears to be functioning just fine. My bitrate is 5,424. I don't see why OBS would be... Like, my resources on this computer seem okay. But my... Hold on, let's make that smaller. Dropped frames are at 20%. Oh, is that visible yet? Can you just see that? Oh yeah, I have to... There we are. 21, so... Bezos is taking resources from Twitch. Yeah, it might be an overall Twitch problem at this point, because I don't think my computer is like... Here, let's get a monitor on here. 48% of memory, 70% of CPU. That's a nice place to be. It's not like this computer is bored. It's not doing anything complicated, but delay is a lot now. Very, very delayed. Twitch issues. This doesn't really tell you a lot. Nah, not much of an uptick in problems. I don't know, guys. I'm doing everything I can on my end. Ben is super smart, but I just don't align with his views. Well, that's yeah. There's a certain nuance to that whole thing. So it looks like, I can just blatantly connect this thing and start using it and put it onto a COM port. Serial supersede USART. Generic serial supersede USART. What does that even mean? HID bootloader. And then the COM. Yeesh. Emulator and programmer dongle. Windows only. Oh, you gotta use that thing. I've used this before. I remember this from synthesizers. We would have to locate those pins so that we could get SW clock and SWDIO. Oh, good. Let's hammer things upstairs. That's cool. So do we still have that? I think I still have ST. What is that called? Oh, wait, there it was. STM32 Cube Programmer. All right. 3 minutes behind. Definitely hit refresh on that. What is going on? You guys are back? That's gotta be Twitch. That's not, I've looked at everything that I can. I'm only uploading at 1080p and we've got all the bitrate in the world. Although bitrate was red for a little bit, now it's green. Because I'm at 49, 4.9K. So this would be what we would use if we did it on this method. The STM32 Cube Programmer. What are the pins on that? STM32F103 pinout. Oh boy. This may be, that's not the right picture of a chip, but it's good enough. Okay, why? Somebody is smacking something upstairs, and it's really bothering me. Thud, 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 thud. STM32, that's what I use to hack my Dymo printer to be able to print generic labels. That's neat. Does ST-Link work on JTAG? I don't know. What are the names of the JTAG pins? Because I have a JTAG header, but this they could have just called it JTAG, and it's actually SWDIO or whatever that is. Because yeah, it does seem like it uses the proprietary one, not JTAG. In which case, the label is wrong. But they didn't seem very charitable with their labels. Man, if you're going to use an STM32 and it's like a perfectly reusable microcontroller, just give us the pins, give us the labels. Why can't you just label it? Nice. That's 3 pins, and then those 3 pins go. What are they? They go around stuff. Yeah, they're there. 3 pins right here. So those are the 3 pins that come from the JTAG header. They come out and around and go to these 3 here, which are that's definitely not. Oh yeah, VDD and VSS, and then you've got PA13, which is Sys JTMSSWIO, but then the next ones are PA13 and PA11 and 12. The USR TX and RX are down there a little further. Clock, IO, and reset. Because yeah, we would be over here, unless they do some weird stuff and they make their way around to reset, which is over here. Those are SPI. GPIO out. It's a shark on the underwater cables. Yeah, that's that whole XKCD diagram taken to fruition. The programming humor subreddit kept iterating on that joke from the XKCD of the single programmer that's holding up the entirety of modern infrastructure, and they expounded on it to the point where they've got like AWS on there, and then they've got everything leading all the way down to the shark that's gnawing on a cable. SWDIO and SWD clock. Well, they called it JTAG, but I don't know if that's accurate. So it might be SWDIO, but it seems like, at least from just tracing out the pins, that it's going somewhere else. Oh, those are going to be a problem. I think I'll still be able to, I'll still be able to plug into them because these are the right angle headers that I hate. I really don't like these. So these have the short pin going directly to a header thing, and then they come up and twist, which I don't like because then your pins don't plug in right. You want to have that plastic piece on the top, and these also don't sit as flat. But at least in the application that we're putting it in, it would actually sit quite nicely. So, because there's a big old through-hole pin right next to it, and that allows us to get that distance. The only question is if it'll still fit in the back, which it might not. There's only so much standoff back there. I guess I'll cut the header. I'll sacrifice it. Yeah, I've got a house full of people, and so they decide that they want to cook something, and so why not? Why don't I just cook what I want to cook? And if I need to flatten a piece of chicken, I'll flatten a piece of chicken. It happens that the kitchen island is directly overhead, so I get a full audio presentation of chicken flattening. All right, that'll actually fit just fine. Well, maybe not just fine. Hold on. Maybe not. Maybe not. Seems like things seem to be in the right spot, but it's like, yeah, like there it's not seated. Okay. So without that in there, yeah, that just seats perfectly. So we don't have space for it. I can do wires that offset it, and then it'll fit in here, but it also can't go here. And it certainly can't have pins that stick directly up because I think that'll hit our front panel. Where are my tweezers? I can't hold on to anything. Ugh, use this. Yeah, where do I find out if Twitch is being weird? I guess you just have to know through watching other streams if other people are having problems. That ain't gonna work. That would work if I had the little alligator clips to plug into. A good synth beat titled Flat Chicken. I'm good now? Okay. I guess the bitrate went up to green or something. I don't know. Well, okay, so that's kind of annoying that I can't fit a header in here. Obviously, I could do a header and then cut a hole in the back. Or we could update it with USB. I think I trust the STM loader a little bit more. Like use this to put the bootloader on there, and then we can use something else to load it from there. All things considered, I could also just plug in with USB and then reflash the HID device. Oh, you have to be able to get to the boot button. Where's the boot button? Let's take a look. Where was that? It was another tab. Sorry, losing my mind. VSS boot 0, 1, 2, 3, 4, 5 pins in from pin 1. 5 pins in from pin 1, boot 0. I may opt to do all the rolling around on the ground on my own. All right. What is going on with my preview? My preview's all messed up. There we go. What a bothering. Where is my chip? Chip. So pointer, I need a pointer. And then pin 1 is, I think, this way or something. But anyway, boot 0 is 1, 2, 3, 4, 5. There. Oh, jeez, I can't even. Okay, hold on. I gotta keep this really still. R15. Jeez, R15. So I think it goes into the rows and columns, which would probably get like a ground signal, and boot 0, I'm not sure how that circuit works. Oh, there's multiple different ways to do it. Very easy to identify boot 0. You can see the figure below. This is a special function pin for the microcontroller. It is not multiplexed with any GPIO functionality. Why does it look like it is? Why does it look like it is? Am I counting wrong? STM32103, that one's a C8. Ours is an RB. I don't know if that makes much of a difference, but pin 1 is clearly here. And 1, 2, 3, 4, 5. Pin 5. Ah, jeez. All right. Is that really R15? No. It might be R6. It might be the one that sneaks in here and goes to R12. In which case it's all the way over here. And it still feeds in to all this nonsense, which I'm not too keen. I would expect boot to be usable by JTAG, in which case it would be this row of pins, but there's our pin 1 indicator, so clear as day. Let's look up the specific STM32. STM32 F103 RB, because it's clearly a B. What the heck is this thing? Medium density, performance, Lion Incorporated, blah, blah, blah. Let's go. Come on. I feel like I've had a board like this before. This is not what I expected to be doing today, but hey, welcome to microcontrollers and stuff. It's totally fascinating. Circuit diagram. No, that's for their board. 128 kilobytes, 72 megahertz CPU, motor control, USB, and wait a minute, CAN bus. Let's just see what we got here. Medium density. Get out of here. (32) RB. Well, it's 103, F103, R. So what does RB tell us? What is that? This is like a 500-page microcontroller data sheet, so it's very difficult to get the information that you're looking for. Like, this is just the revisions table of things they've changed in the... Oh, God. Oh, so we have 128 kbps, and we've 64 pins, 128 kbps. That's actually a pretty nice microcontroller. In the docs, pin shows in the top left based on the silk screen. Your chip is on the bottom left based on the silk screen. Huh. They had it custom punched from the factory to be confusing, to be slightly confusing. All right, pin out. It's like 150,000 pages. This stuff is ridiculous. Do 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 do. Nope, nope, nope. Oh my God. There we go. There's our buddy. That's 100 pins. That's not us. That ain't us. That ain't us. We're the 64 pin. LQFP64. Okay. So yeah, again, pin 1, and then boot 0 is there. And then VBAT is pin 1 going to there. And then I can't see where it goes from there. Yikes, chat. This is a lot. We can get to the bottom of this, though. I'm dead certain it's not an 8. There's a flat line on that 8. You can see it. They have the equipment has gotten good enough these days. No, this board does not have a backup battery. Yeah, pin 1 says VBAT. That goes over to here, and that's just next to the potentiometer. It's one of those, and it probably goes over to the JTAG socket. What about USB pins? Which ones are the USB pins? So we traced the USB pins a little, and the USB pins come from over here. One of them feeds into a voltage regulator, an LM1117, which makes this exactly like all the other music stuff we've looked at. It uses the same voltage regulator. I think that's just safety. But our pins come through here, and they hit the typical USB resistors, and then they drop down to the other layer of the board. And on the other layer of the board, I believe it's this cluster right here, they come over, across, and into the chip. And if our pinout is correct, that would be VDD VSS2 PA 13 12 11 10. 13 12 11 10, looking at our generic pinout over here, 13 12 11 10, it's somewhere in this cluster. (13 12 11) JTMS SWDIO, blah blah blah. 10 and 9 are US Art RX and TX. USART. I don't think this is a very extensive pinout. It's not like the Arduino ones we usually look at. I'm just trying to find like other unique pins on this thing that have a particular designation, just to make sure that we're in the right place, because I want to be able to know where that boot T0 is. Where's boot to 1? Is that on here? No. PA0 wake up. PBs and PAs. Tamper. Real-time clock. What? 32 in. I wonder where the CAN bus stuff is on this. What just happened here? No, I don't want to highlight. VDD VSS. Pin 60 is boot. What are the pin functions? Easy, just download Cube IDE. Huh? I mean, I got the Cube programmer. Shouldn't you be able to test it by ohm testing VIN or something? Oh yeah, I can obviously ohm test it. I was hoping I could get it through Ingenuity. And a part number. Because these pins are pretty small and ohm testing is going to be kind of annoying. So ohms on that. And then looking at the various JTAG pins. Okay, so JTAG. I guess all bets are off when you've got a one-row JTAG. Yeah, it looks like it's proprietary when it's one row. It only really needs 3 pins and power and ground. Because it's reset TXRX or SW, whatever they want to call TX and RX. Power, ground, reset, TXRX. So obviously that one is going to be ground. I should get here, move this closer. I gotta not whistle that loud. So there's that. That's connected there. Obviously ground is in the middle. Power could be maybe on one of the ends. That's probably going to be 5 volts, so it's hard for me to find a test point for that. I mean, I don't think these will... Oh, 600 ohms. What about you? 150 ohms. Well, I guess maybe those are floated between power and ground. I don't know, 600 might not be the good indicator of that. What I really should do is test it from this pin. That's actually an easy one to park the probe on. So from there, oh, we can just do this from this side. Oh, there it is. Yeah, see? So from here, it even has an inductor on it. Here to here, 0.4. Yeah, so power, ground, and then probably, well, we don't know which one's TXRX and reset, but they are there. So the reset pin is supposedly like there. Boot 0 is, so VDD VSS 9.8 boot. VDD VSS 9.8 boot. So this one here. Maybe, but I'm not certain about that. Pretty much hitting 2 pins at that point. Wait. DDSS 9.8 boot. Oops, careful. I don't want to damage these pins too. It's 1M. That doesn't seem like the right pin then. Google says clock state, data in, data out, test reset, volt. What does Google know about shit, man? Come on. Google doesn't know what the hell they're talking about. No, with ARM, with the ST micros, it's called something else, but it is essentially a reset pin and then a TX and an RX. So right now we're looking for the boot pin, which is essentially the reset pin, because if we're going to program this thing, we need to assert a voltage level on that when this thing boots up, so it knows that it can take in software. Based on your pin 1 marking, aren't you rotated 90 degrees? I mean, in this thing, it's pretty explicit that the dot is there. If we were 90 degrees, then it would be over here, wouldn't it? Yeah, AI is always going to come up with a annoyingly confident answer that's not going to be necessarily right. For us, we're looking for boot T0. If the dot were here and boot T0 were right directly next to it, then it would be over here. It would be on this side of the chip. But it appears to be here. That's what I'm seeing from these, although those are going over like that. So maybe it's not. Maybe it's not. Maybe if pin 1 is there, and it's actually marking pin 16, that makes no sense. Let's see if there's any precedent for it in the datasheet. Actually, what could also be happening is this is not a top-down view. That doesn't make any, does that make any sense? That doesn't make any sense. If this were flipped, nah. Because these I don't think are, I think you're looking through the chip. And on this one, you're just looking at the edge of the chip. That's 48 pins. I don't think that's what we have. Because we have the RB. Pin 1 and 64 right by U2 would be my guess. 1 and 64 right by U2. That's what I'm thinking too. Yeah, because that's our big dot. We've got a big dot on the chip. Big dot. The marking doesn't matter. You can put that anywhere when you design the board. It's typically where your notch is on the thing, and that's where you're counting from. So pin 1 is here, pin 1 through 16, which makes this boot 0. And so I'm trying to ohm out boot 0, but it comes over to these 3. But it's weird because, like, it's just going to, like, PA 13 and 12. Using the markings, like the lasered on markings, to tell you what pins there are, that's not unprecedented, but having the pin 1 dot not agree is a little strange. Boot 0 would be in the row where U2 mark is. This row? Oh, right. No, I get what you mean now. Yeah, me being off by 90. Okay, yeah, sorry. I'm advocating for things that I'm not understanding properly. Yeah, 13, 12, 11, and 10 are over here. That's where I thought I traced them to. But if boot 0 is the way that it is in the manual that we're looking at right now, it's actually 1, 2, 3, 4, 5. It's this one here. My guess is maybe JTAG is connected with pins 21, 15, 9, and 7. Oh, that's such a weird... 59, I think or no, 21, 15, 9, and 7. 15 is at the bottom of this row. But I don't think, I don't know, I'm not seeing the JTAG. Can I, hold on, let's see here. So 1, 2, 3, 4, 5. Okay, so that is R15. This is supposedly boot 0, which we would have to assert something on. Quick Googling makes you think that the actual interface is UART. No, UART. if I was better with STM32, and I'm not saying I shouldn't be, this would be way easier, and we could probably have taken it over already to some degree. Yeah, we're gonna have to replace the UART on it. I don't think I have a chip clip that's this extensive. I could solder some wires to it. I was hoping that JTAG would be like our end all be all, but it's possible they've programmed their own like bootloader on the thing that's using this as the input, and it plugs the input into generic IO, which is like PA 12, 11, 10, and 9. Although, oh no, never mind. There's nothing over there. 12, 11, 10, and 9, there's the JTMS SWDIO is there. That's possible. SWDIO, I think, is one of the pins that we want, but STM32 JTAG. Oh boy, that's a lot of stuff. That's a lot of stuff. Well, okay, the blue pill board, okay. Do I have any of those? No, I don't. I don't think I have any of those. STM32, oh, there's the debugger that we have. That's the one that I have. JTDI. Standard JTAG. So, I mean, I feel like it might be following the standard. Does not use ST14, nor does it contradict electronic assembly. What? Ugh, damn it. No, I don't know. This isn't specific to this microcontroller, it seems. But let's take a look at a blue pill schematic. Boot 0 and boot 1, going to those. STM32, C8. USB M and P are on pins 32 and 33. And in our case, they are going to pins... I'm just going to look to see if, because maybe this was developed on the blue pill first. That's like, so that's pin 64. So that is accurate. Let's see, pin, well, that's 46 and 45 or something like that. I would like to get the probe on that and see which one's which, but maybe not UART. I imagine they're using the header to flash the chip from the factory, so the bootloader would be irrelevant to them. I would wonder if they're just flashing the chip directly from the factory, and this is just left over from when they were developing, and they used the JTAG, you know, internally in order to program it themselves, which is what we would love to do. Although it would be a very convenient way to get a bootloader onto there. So I was just looking at what pins USB's coming in on, and it's like PA 13, 12, 11, 10. So that's like these right here. Which on the blue pill, it's using 32 and 33. 32 and 33. These, no. Wait a minute. It's a different chip. It's a different chip. It's not the same chip. It's not, damn it. It's not the pinout. That's not the right answer. Son of a bitch. Huh. Because we're the R8, not the C8. RB, rather. Sorry, I just saw the 8. Okay. All right. Trying to think on my toes here, chat. STM32R8 schematic. Maybe throw an Arduino just because. That is not, nope, nope. Can someone transcribe a schematic? Help me with my engineering homework. F103R8. Ooh, I don't know about Instructables. Time has come for me to try one of my 32-bit ARM microcontrollers available these days. I'm not going to give up with 8-bit worlds, so no way, blah, blah, blah. Microcontroller have more speed and peripherals capabilities. STM32F103RB T6, which I found both cheap development board and opportunity for standalone chips. That looks familiar. We don't have a clock on ours. USB power supply. Microcontroller. So this is using their software to figure it out. In the middle of terms of performance and memory. Charts from the FT. Okay, blah, 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 blah. One serial RS-232. These are the peripherals on the board that they've installed, not what we have. They could be on different pins. We're just trying to see if we can get a connection here. I've got the datasheet pulled up, and the datasheet, you know, it gives us the stuff, but it's not what I'm looking for. This is the datasheet. This is the exact one that we have. This is the pinout that we have, but it's just going to tell us that we're on PA 11, 12, and 13. I'm trying to see if there's like a more, I don't know, common pinouts between things. Like, for instance, the JTAG pins being on this part of the board. Boot 0, PB7, PB5, NJ Trust. I don't trust New Jersey. They got boot 0 going to a boot 0 thing. It's got like places to be. But then over here is the JTAG. That would be like these pins down here, which those clearly go out to rows and columns. Strange. I don't know. Maybe we have a unique pinout. You know, you can shuffle it up with these things, and perhaps that's what they're doing. I'm learning as we go. So I don't see like dedicated USB pins either. Seems like it is just fast enough to do USB. Seems like it should go to some kind of like a chip to do that though. JTAG and SWD. NJ Trust, JTTI, JTCK. So JTAG, data in, mass chip select or whatever, clock, data out, and then reset. No, I think what the yellow marking is that it's been programmed and it's ready to be installed. I think that's probably just how they keep track of their internal chips. You see it a lot where they put a dot on the ones that they've already programmed, and I could probably scrape the dot off. There's just nothing really really important underneath that. It's just like lot tracking numbers in case a lot goes bad. That seems to be the direction that we're going. Yeah, is I'm gonna have to go pin by pin and figure out what all is connected where. Not incredibly complicated because it's a very common circuit. There's not a whole lot. SWD JTAG should be fixed, so that should always go to the same pins, but it doesn't appear to on this. Doesn't appear to, unless theirs is a different pinout, which we specifically looked up the RB. This one is an RB. STM32F103RB, which would mean data in and clock are pins 49 and 50, which are these two here, which go down and over to the matrix instead of to our very clearly labeled JTAG port up here. Because the Jitagi port, we have going to these. Or is it these? Is it those? Maybe it's that one. Maybe it's this. It's the whole thing. I don't know. Very strange. I'm fascinated and frightened simultaneously. I'm scare-roused by this. 100 ohms. What? That's a connection. That was a connection. Yeah, that one's definitely connected there. And that pin, according to this thing, is PB11. No, what are you? No. Okay, hold on. Yeah, I'm really gonna have to do this on my own, aren't I? Welcome to my Wednesday. I was gonna spend it doing physical stuff. Nope. Nope. Okay, that one doesn't appear to go there. Does it go up here? Aha. But again, that pin is JTCK. Okay, so that's JT clock. So then this one here would be the last one. JTDI? Nope. Of course, that seems to go through a resistor too. Nope. Is it over here? Nope. 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 Come on, man. I may need to start an MS Paint document. Oh, or does it go down there? Wait a second. Wait just a second. If that one is the JTAG boot pin, then maybe it does go over here. So if maybe this one here, I don't know. I don't like raking the pins like this too much because it like moves the solder sometimes. Nope. Barking up the wrong tree. Man, this is going to take a little bit. It seems like, so our pin one's here. We go to the opposite side and we get to our JTAGs. And so the JTAG here, I was actually able to get on the other side. This one ducks in and we don't know where it goes from there. And that one might go to one of the other JTAGs. I'm not sure. Unless, wait, that one in from there and goes up here to R1. And that could be one of the pull-ups for JTAG. But then JTMS is this third pin right here that goes here. I guess it can make its way to one of these. Like the signs are close. Power, ground. One of these is a clock and the other one's the other two. So, okay, I'm starting to get it a little bit more. Now, hold on, chat. Graphite MD13. Samson is not going to give us, nor is the manual, which is unfortunate. Hey, Ryan Labs, how you doing? We were going to do more physical stuff today, but we discovered that this MIDI pad has a familiar microcontroller on it, something that we've used before in the music stuff, that we could potentially reprogram, take it over, make it work using Arduino software, which makes it easier on me. And then I can make it into a CAN bus accessory so it can speak to the rest of the simulator setup. Because I'm not using it as that, I'm using it as a button pad for playing sim games because it has all kinds of cool controls on it. It's got all kinds of cool stuff, and you have these big cartoon buttons. You're doing legal stuff? Oh, wait. Appeal on the thermostat. Oh, that's still right to repair stuff, right? Yeah. I think we're the first person to try to reverse engineer the graphene M13, graphite M13, whatever. Unfortunately, music stuff, if you go back far enough, if you get into the early to mid 90s, is probably about the cutoff of them including a schematic, and then also having such analog electronics as to need like a repair guide, that we found out with the M303, the original 303, the MD 303. I forget what the number designation was. It wasn't just the 303 because there's a couple. But the one generation of it, you could actually find a fully comprehensive electrical schematic that gave you voltage levels and stuff too. Why is something itching really bad right on top of my lip? Weird. Beard ownership problems. But unfortunately, we are in the modern era where things like this you just don't get a schematic, which is not that bad of a thing because this is such a simple device. The other one would be kind of neat to have a bunch of faders on, but I don't know what you would do with that in a game unless you really, really, really needed trims. iPad and USB powered. Hey, there you go. It's a cool little piece of kit, but I'm going to have to sit down with a pen and pencil and just figure out where all this stuff goes. It's much easier to, when you have this many pins sitting next to each other, it's much easier to categorize them initially and then just let them stack up on each other, and then you can fill in the blanks and go, okay, so that definitely goes there. Because with these tiny little pins, even with my super needle thin probes, it's very difficult to get at all of these different pins. But this is, again, another piece in the long saga of me getting in and reverse engineering something and turning it into a CAN bus accessory. The really cool part about this is that it's possible that I can flash and reflash it using JTAG. It uses a 7400 series MUX in order to get all the analog pins into just one big ARM chip with tons and tons of pins. You find this all over this kind of stuff where they'll use just one chip that does a ton of stuff. But this thing is fast, it's relatively modern, and it's got Arduino compatibility directly out of the box. So I'm looking forward to getting in here and being able to reprogram this thing. I'm not totally certain about connecting JTAG right off the bat, because again, there's a couple different strategies for stuff like this depending on how hardcore you're into microcontrollers. So if you're wondering what we've been doing for the past hour and a half, 2 hours, is we are trying to vet out whether or not they are using this microcontroller in the way that everybody else uses it. STM may be read protected. I'm not trying to read it, I'm trying to write it. And even if it's write protected, I think I have some in a drawer. Or I can order another one and put it back on there. The thing is, how hardcore was the OG engineer into their microcontrollers? Did they drop this into a ZIF socket and put the bootloader on there and then transfer it to the board? Is that JTAG socket just there as like a vestigial, there's the word I was looking for, as like a vestigial part of development? Or were they getting into it through USB? The USB doesn't seem to be on like the commonly used USB lines, but it seems like the micro is fast enough that you could just assign it to another line. If the JTAG is not connected precisely with JTAG and they decided to use somebody else's bootloader where you could just choose new pins, or is JTAG locked down to a certain set of pins? The boot function, I'm still wondering about too, because the boot pin appears to just go out to the keypad. So how do we initiate a boot sequence out of this thing? Or do we need to do that with JTAG? I don't know. So these are all the different things that I'm vetting out, maybe sometimes multiple at a time. Let me, I'm going to turn off the fan and close the window because it's getting, it is very cold. I'm shivering a little bit. Having a lot of trouble regulating temperature in this house today, just because there's multiple people here and they get cold. But yeah, anyway, I wanted to put the 3D prints onto this actual thing. Maybe I'll do that tomorrow as a break from reverse engineering this MIDI pad, because the MIDI pad seems pretty promising. The other electronics is just me hooking it up to a thing and then you know, telling the thing what to do. This one would be reconfiguring and reprogramming the brain of an original device. I'm impressed with this MIDI thing because all the electronics have been pretty simple. I mean, it's built with the same technology that mutable instruments, modular synths are created. Do you still have snow? Not for long. It's going to be 70 degrees in the next couple days, and that's going to stick around for like a week here in Pennsylvania towards Philly. We do have snow on the ground, but yeah, that's not going to last. Yeah, so I wanted to physically work on this thing today, but maybe that'll be better for my my off day, and then we'll come back and do more stuff. I want to get a schematic of this thing, so I need to start in on that because we have LEDs and then we have buttons, and then I need to, like, once it's Arduino, I can hit the ground running with it though. Oh God, I've got rail stuff. I'm like trying to sit here, but there's like it's just stuff everywhere. Oh my God, what a project this has been. It's been a lot of fun though. We're just not making an incredible amount of progress because we keep running into things that are just utterly fascinating, like the shifter being two separate devices and having some weird relationship with CAN bus. One of the big things that I need to do next is flash Node-RED onto the Arduino so that we can start playing with signal integrity and stuff. Gotta go do some work. You popped up. You popped up frigid. I drop in and smashed the like. I appreciate the smashing. I don't know what the other words mean. I'll take them though. Yeah, if you guys haven't checked out Ryan Labs, check out Ryan Labs. They're doing a lot of cool right to repair stuff right now. I don't know if they're streaming or anything like that. Just check them out. I don't care. Okay, if we're going to get in here with JTAG, then we need to kind of categorize our JTAG, and so I need to start this schematic. And so to start the schematic, it's a fairly complicated and involved process, but I'll show you guys how I do it. What I do is I open up this program called MS Paint. You just have to type MS Paint into your start menu, and then this program comes up, and then this will allow me to record all of the different connections of this board. So actually, file save as, and this is going into the Merc wheel project, not the stock tester. This one, new folder, and this one's going to be MIDI pad. That's going to have a software and a picture in it. MIDI pad. And this is the start of it. So here we go. We'll do USB next because that'll be a nice easy one to do too. FTDI. And then we of course have a line here. Probably that's a little better. And circles for pins. So pin 1. Actually, that should probably be a square because it's pin 1. Although it has the line. The line designates pin 1. That's that. I'm going to cut and paste that. Why do you do it like this when you could use XYZ program to do it? Well, because this is just so simple. I think that's the number of pins we have, right? Nope. I clicked a thing and it did a thing. Yeah, 5 pins. Okay, so just take the floor, bring it up. There we go. Okay, 5 pins. For now, I'm just going to do signal flags where we just put a name on the thing because this STM product, this schematic is going to be enormous. A lot of pixels are going to go towards this. It has so many, it has 64 pins. I mean, it's going to be ridiculous. So I watched, well, okay, so I'm still behind on it. I haven't watched in like 2 days, but I've been getting through Cyberpunk and Edge Runners, rather, not the game, or a tabletop. I don't think Franz Ferdinand was a good choice for the theme. I don't think that was a good choice for the theme. I don't know. Some of these animes, man, when they're choosing a theme, I think sometimes they get away with quite a bit. And there's a lot of sort of generic anime music bullshit that I really don't like, where they start off with like a really nice concept for a song, and then suddenly they pivot in the middle of it. Well, towards the beginning of it, really. They pivot away from the really interesting idea for music, and they do generic stuff. Like they do that a lot with anime music. Or they'll take a real song. And in this case, they took Franz Ferdinand, which is appropriate to the game. This fire is out of control. I'm going to burn this city. But what Cyberpunk did is they edited it so that it worked better with a theme song for a cartoon. And they took out the I'm gonna burn this city line. And it's so obvious if you know the original song, if you grew up with that music around the same time, like I did, hearing Franz Ferdinand on the radio, this fire's out of control, I'm gonna burn this city, right? But instead of this fire's out of control, I'm gonna up, and like, it doesn't work. Musically, like, the verses aren't, they cut the I'm gonna burn this city part, and it's so obvious. Really weird decision. Really weird decision. I don't know, man. Oh, how I burn for you. Okay, so this pin is power as far as we're understanding it, right? So if I go to this here, that should be an connection, right? Yeah, okay. So first one is 5 volts. Jotting stuff down is really helpful for doing something with 1.5 billion pins. And this one's ground. So what is this one? This one goes to... Where's my other probe? I lost my probe. Nope. 100 ohms. So, boop, boop, 3. This is where having multiple monitors is really nice. But because I'm streaming to one monitor. PA13. Does that have any other identity to it? SWDIO. Yeah, it's probably 3 volts. Let's not sweat over this stuff. Although we will sweat over it when we actually power the device so that we don't blow it up. So which one was I looking at? Is this one, right? PA13 SW. Studio. Okay. I double check on the voltage. Well, we do have a voltage regulator. Yeah, so USB is coming in. And that's a micro, I think. Yeah, so it's got 2 pins to ground. So it's, what is it? It's that's also 5 pins, so I'm just going to steal this. And this one's going to be to 5 volts. Whatever. Doot. One of these. 1, 1, 1, nah, 1, 7. Out of there. Maybe 3v3. And then ground. Then these two are ground. I'm just doing it quick. I'm just getting down what I know. PCAD, you've matured enough. No! MS Paint forever. What's the order of USB micro? Just so that I'm accurate. Mini. USB mini. ID's not floating in this thing. See right there. You guys may think that I'm not good at this, but I saw this immediately. Excalidraw in Obsidian. No, Mario Paint would be the ideal way to do schematics. D minus, D plus. D minus and a plus. Actually, the real way to draw this, because 5 volts might go to some internal stuff, but what I really should do is have 5 volts on the other side. Because that's where it's coming from. Although, if I internally use the 5 volt symbol, it should be on this side. So it's debatable where and there's probably going to be, I'll put it over here. It's actually, yeah, 5 volts internal to the board. It's not using 5 volts anywhere, but it gets a little weird identifying and labeling schematics. I just joined the stream like 20 minutes ago. Cut me some slack. None of you get any slack, because the first any little bit of slack that I give you, you guys immediately pivot and suggest that I use AI for something. For some fucking thing like doing schematics, or maybe I should let an AI think for me and let my brain atrophy into a little pile of mush and become an iPad kid. Maybe you should do that, Bother. Why don't you do that? No, we hone our skills in this channel. Got to be consistent schematic conversions when using MS Paint CAD. I'll tell you something about schematics. Schematics are a communication to either future you or another engineer that you do not know. And so generally I have certain conventions that I stick to. You do not change your conventions within your own schematic. Things like, for instance, when 2 lines cross over one another, I don't do anything. I do nothing. These lines are crossing over one another. They are not connected. When a line is connected, I put a dot. But if I forget to put the dot down, I never have 4-way connections. Unless I absolutely have to. No, you don't do that. Because if you forget to put a dot down on something like this, and this exists somewhere within your schematic and you're allowing those two to connect, it looks like they're not connected. If you disallow 4-way junctions and you simply add more junctions with dots and only ever have 3 ways, this is a connection. And you can see it as such because there's no other way to interpret it. There's not another line coming in here. Generally, the flow goes from upper left to lower right in terms of functionality. That gives you a nice big pocket to put your whole power supply in the upper right. In our case, we're starting with power and data. This is where all our stuff comes into our stuff, you know. No earlier than AI will be operating your OSC. I'm so close to just going with Linux on this computer. The only thing holding me back is AutoCAD. And it's not just for MS Paint CAD. CAD programs will let you get away with so much. They will let you get away with so much in terms of having weird things that can affect. So, you know, making your resistors look consistent, making your capacitors and your putting the U2 R1 R2 label on a particular part of the resistor and keeping it somewhat similar around there. There can be exceptions, but they are, side cases. What we're doing right now is I'm getting this schematic down just so that I have all the information in front of me and logged and permanent, because we already vetted it out a little bit. It looks like things sort of follow the right hookup schema for this. I was just watching a bunch of Joel's Varg Skeletor Windows 98 destructions. Those are fun. He really messes them up. He basically just clicks on everything he can until the operating system explodes. All right, so just to get USB fully into the chip, because I think I can do that very quickly. USB comes in. Power goes to some kind of a clamp diode. I believe that's probably a diode, because one is on ground and the other appears to be floating. Yes, it's probably a clamping diode. Let's just extend this out a little bit, just so that D plus and D minus has a little bit of room to exist. This needs to be that size so that it's consistent. And then I am going to just draw it as a diode. Would it be, might be, I'm not sure. Hold on, let's diode test it. Out of control and I burn, oh how I burn for you. .3 volts. That appears to be the way that diode goes. Let's reverse it. Why would you put the diode in there like that? Unless it's a reverse protection, or if they're running off of, oh, there we go. Yeah, it is reversed. Okay. I believe it's clamping diode. Why you would have that in there, unless you were working with musical stuff. That or it's just a static suppressing thing, and it's not actually a diode. But we did get 0.7 volts, so I don't know. And then, what do we have next? Just a big cap. Okay. Why is the 1117 mirrored? It's actually a 7W111. Hinky 247 with a 2-month streak. Hey, thank you so much. What's up, Hinky? How you doing? Yeah, it might be a TVSD diode for ESD. That's probably, but that's a lot for them to go through. I guess this thing is like, I don't know. When I bought it, it was much cheaper. This seems like something that a more expensive thing would do. And an 1117 would be more like what a some kind of other musical device would use, right? Like a synth or something like that. Why is it mirrored? Because you don't have to stick to the pinouts. Your pinout does not have to be exactly what's on the chip. I mirrored it for convenience. It's 321. It's just backwards. We're looking at it from the other side of the board. Okay. The important part is, what is D minus doing? D minus is going to a 220 ohm. Just double check. I don't need to know this value really, to be honest. Back to ohms. I have to reverse engineer with my purpose in mind, which the purpose in mind is to quickly be able to take over this device and turn it into something that's going to work on the simulator setup. I don't need to know extensively what everything is and where it is. So 22 ohms. Another 22 ohms. And it appears as though it splits right here. Yeah, it does. And it goes to a 2.2K. And then that goes somewhere. Weird. So 22 ohms and a capacitor to ground. So just to make it easy, I'm going to draw a box instead of a squiggly line. I don't want to put the label on it. Whatever, 22. That one's 22. And then D plus, because it's the minus and then the plus, yeah. D plus, well, they both get a capacitor. I'm going to try to make that extra small. Tiny little cap right there is just a filter. And then this one goes off. This one goes off. But then we've also got a 2.2K that also goes off. Okay, God knows where. Okay, that's a little clamped. It's a little cramped, but we can live with it. Let's do a freeform selection, and I'll take all this stuff and I'll pack it in a little bit. It gives us a little bit more room for text right here, because this goes off to a microcontroller pin almost directly. So I've got 3 points of interest right here. And that's those 3. So 22K is on the bottom one. We can follow that visually. I could take a picture of it and then I could flood fill. It goes all the way to this pin. 1, 2, 3, 4, 5, 6. Which I think is PA 11 or 12. Let's take a look. Hold on, you guys. Normally, I would have all this reference material up on the other monitors so that I could just glance at it, but I can't. 1, 2, 3, 4, 5, 6. USART 1RX. Oh. That was the one with the resistor on it. PA 10. I could just cut and paste that text. Use art 1. And that's RX. I don't think they're using it as that. Yeah, because these pins have multiple functions, so I don't think they're using USART, the universal serial ART. I don't know. Weird that they're not integrating into the USB PHY inside of the microcontroller. That's what I'm trying to. That's what I'm getting to. Yeah. Which one is the wrong package? This one? F103 SPI, currently working on low RAN C8. Okay, yeah, so that is the wrong one. Let's get rid of that. That is the wrong one, although this one was specific to the different pinout. Yeah, that's not the right one either. So we'll go to the data sheet, I guess. Although these were lining up just fine. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 16. Okay. Wrong one. Possibly the source of the confusion. I don't know which ones those are. Which one does that use? This is a different... That's not the R8. We have an R8, which is a different pinout. It's the LQFP64 pin package, so we're dealing with 64 pins. even though 13, 12, 11, 10 lined up properly. We'll have to get their identity from giant table. Ugh, I hate doing giant table. Once we get them down on the pins that they're going to, we can take a look at what their identity is on the big table that will properly identify our chip, the one that we're using. So that was the 2.2K. Yeah, isn't it great? It doesn't just have like an epoxy top on it. It's got just like the full bore ARM chip, which I love. I would buy another one of these if I wanted to spend $60. Handsome Boy Modeling School. Just get $60. You won't regret it for long. Let's see. So the USB comes into here. USB plus is the one on the bottom. And so that goes over here to that. The one on the far left and the one on the far right of the USB minus pin. All right, so USB minus pin is in the middle. The one on the outside, which is the one with the resistor, that one goes to PA whatever. This one is the one without the resistor. That goes to the fourth pin. The fourth pin is PA12. Any other identity is TBD. And I'll get rid of this because I don't know if that's correct on this. The special functions of the pin. Usually you get like the PA would be the pin bank A, and you get notations like that. So A and B, or bank 1, 2, 3, and 4, bank A, B, C, and D. All those is registers inside of the microcontroller that are binary numbers. And the binary numbers represents the state of that pin. You can take them over using that method. Analog pins are different, obviously, because you need more information to get the analog pin. But for the digital pins, they usually have a voltage threshold that makes them a 1 or a 0, and a detection threshold that makes them detect as a 1 or a 0. Okay. I'm going to do GND just to make sure that that's clear. Although really I could, well, no, that'll just, it'll muddy it up. Look better if I just do that. Okay, PA12, and then this one's PA11. Yeah, and then that one's PA10. So we know where USB's hooking up. We need to finish off the FTDI. So if I go to our FTDI, we already know PA13, which is this one here, is connecting to this top one. And from what I can see, let's focus the camera a little bit. It would be logical if these two just went directly down to these two here. One of them sneaks under the board, the other one goes to this pin on the side. And we get an ohms from here to here. 0.6. Gucci. Cool. What is R1 doing? R1's on whatever that is. We'll get to that later. All right, so that one goes to PA14. PA13 and 14. SWDIO maybe. And then the last one, I don't know. I want to say it should probably go to boot. Where else could it go though? PAs, PBs, VSS, VDD, 1, 2, wake up, maybe? So it's possible that it's over there. Let's just check. So if I go from here to the VIA, Come on. There it is. So yeah, that is that signal. We've made an assumption, and so we've made an assume. And one of my guesses is this pin. Nope, let's rake it. Rake the pins. Yeah. Go here. There's 2 caps on that pin, so I think that's a standard STM. This is for like clouds, I think, uses one of these. So I had a lot of trouble with clouds. No, there's no FTDI chip. No. We've already traced a bunch of the FTDI quote unquote pins to the chip. They go directly in. They don't do that anymore with the separate FTDI chip and the serial device. Well, that's what I was checking. PB4 is not, well, I don't know where PB4 is, but it's definitely not like that pin. These are all going out to matrix pins. So, there it is. See, look at that. I just fold down the, I don't want to do that. It's fold out the solder using these probes. 1, 2, 3, 4, 5, 6. Check with 5. Yeah, okay, we're not connected. It just looks, that little glint is worrisome. Oh, yeah, see, we're ohming on both of these. Oh, that's because I'm leaning against that other pin, yeah. Okay, so it's definitely this one. I mean, definitely this one. Definitely this one. 1, 2, 3, 4, 5, 6, 7. And reset. Nursed. Where the hell else is nursed going? Why would nursed be going over here? You shouldn't be able to use nursed as another pin. Is it going to that? Is that a capacitor? Is that what's going on? It's just going to a cap to stabilize it. That's what it is. So you don't randomly get resets when you wave static electricity over the board. There, I got a better way to probe it. U all the way to the cap. Ding. Okay, and reset and a capacitor. That's what, so what confused me about that is that it looks like it's one of the matrix pins. C23. The random 33 ohm series termination resistors. Whoever designed this loved their app notes. These are 102s though. Oh, these guys? What is there, like a matrix pad app note? I'm sure this device suffers from really hard bouncing when you hit the buttons, and they kind of wanted to filter that out and make it, you know, more of a stable music playing device. Okay, so N reset PA14 and PA13 on the B8 version of the STM F103. I know it doesn't sound like I'm speaking English, but all this stuff like matters. It's the details that matter and stuff like this. And I know it's weird and I sound oddly familiar with all these weird terminologies. It's just because I've worked with stuff like this before and you need to be so incredibly laser focused. These electronic nerds that are in the chat right now are cutthroat, and they will turn on me at any sign of weakness, just instantly killing me. we need to be specific about the things we're talking about, because the STM32F103 is a series of chips with a series of features that vary from chip to chip. The chips are going to be in certain packages. In this case, the next letter designation, STM32, that's the series, F103, that's the specific like category of microcontroller chips. We have an R, which means we have 64 pins, 8, which means we have 128 kilobytes of RAM. It's wild. It's so incredibly specific. But if I talk about the STM32F103, the chip could look like this, or it could look like this. This one has 100 pins. And so you need to get specific because you're describing something specific. And so in this case, the STM32F103 RB with the LQPF64 pin out. So now we know the identity of our pins, and that's kind of important for what we're trying to do, which is to determine which pins we have to talk to in order to program the device. And as usual, they put it all to a gigantic table. And so now we have to find the LQP. We have to I'm never going to recover from this neck injury. LQFP64. Tables, referencing charts, referencing tables, referencing diagrams. Welcome to electronics. I forgot. LQPBLBIMF64. There we go. LQPF64. So LQFP64, people making fun of having to get used to saying LGBTQIA+, really bother me. They're kind of like the dumbest of the dumb people. They're not even trying to even participate in society at all. When we sit here and we go, hey man, did you see that stream where I was working on the STM32F103 RBT? Oh yeah, no, but I thought it was an STM32F103C7. So like, come on, it's not hard. It is one of the easiest things you could possibly do, and it will make somebody's day if you don't do a stupid joke when you say that. Anyway, our pins are this one. Pins and alternate functions is what we're after. And the pins that we're looking for are PA1314 NRST with a soft R. There I go, making those jokes at PA12, PA11, and PA10. We want to know what those alternate functions of those are, because those will beget, belisle, they'll not bequeath. Bequeath, no, they'll whatever. They have underlying functions that will reveal things to us. So LQPF64, first pin I want to look at, PA13. We go down to PA13. Oh my God, where the fuck is this thing going to be? 1, 2, 3, 4. Okay, PA13 is not PA13. PE, PC, PA. Where's PA13? You son of a bitch. Okay, what is it again? This table sucks. This is a really bad table. PA, pin 46. 46. 60, 50. 46. PE. What? Wait, no, that's not. No, it wasn't PE. Pin, what? Look at the wrong one. This one. PA13, pin 46. So on the LQFP64, this column, pin 46, PA13, JTMS SWDIO. Okay, so it is a programming pin. SWDIO. Software data in out. I'll put 46 on it just to, because later on I'll go to draw the chip, and if I have the pin number right there, it'll be fine. PA14. Drawings, referencing numbers, referencing tables. Cells interlinked. Welcome to hell. Okay, PA12. Right? No, PA14. PA14, pin 49. 49, 49, 40, 49, 49, 49. PF64, 27, 36, 40, 50, 49. SW clock, JTCK SW clock. No, I don't think I need the JTCK. Well, JTAG clock. So it is still JTAG. TCK SW CLK. This one has an alternative too. I need to move this stuff over. That was a terribly drawn 9. Exactly, Legoland. I've discovered your true identity. The other one was JTMS. That's supposed to be JT. Nobody will ever know. JT. Oh. JTMS. I don't like how I drew this. Hold on. That D is looking a little weird. JTMS SWDIO. Yeah, the software or the whatever the weirdo port is. Last one is going to be N reset, which I don't know what pin that is. Nursed is pin. I'm actually kind of glad I highlighted that because I can get back to it quickly. N Erst is. Where the fuck is N reset? It's not. There it is, pin 7. It's just probably going to be called N reset. Where browser? I have so many windows open, you guys. Okay, down here to the table, pin number on the LQ FP64, pin number 7. N reset is just N reset. It's an IO, but it's only that function. That's all it does. And then it went away. N reset, pin 7. That's all it does. Control S. Okay. And then just for funsies, PA12 and 11. 12 and 11. PA 12 and 11. 45 and 44. Something, 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 64. 12 and 11. Huh. PC3. Make sure I'm on the right one. Yes. ADC 12 in 13. But that's 10 and 11. 13 is VDDA. Hold on a minute. PA 12, 11, and 10. On this one, 12, 11, and 10. 45, 44, and 43. 45, 44, and 43. 40, 36, 45, 44, and 43. USART 1 RX CTS, but we're not using USART 1. Timer 1 channel 3. USB DM, USB DP. So minus and plus USB. Oh, those are CAN pins. Those are CAN pins. CAN RX and CAN TX. So 12 is our CAN TX. Oh, that's great. Let's just get that right so I don't mess it up in the future, because that can directly, oh, that's perfect. We have CAN pins that are meant for CAN right there. Oh, on a USB socket that did us the favor of breaking the fuck off. Beautiful. So pin 20, no, 42. That's PA9. No, we're down here. PA11 is CAN RX. CAN RX, and then it's also PA11. PA12 is CAN TX USB plus. So this is hooked up exactly how we were thinking. And I know my writing is very sloppy here, but I will understand one day. One day I'll get mad at myself. As far as I remember, it can be released to be an I/O by some fuse config, but it's likely in the reference manual. We did stuff like that with the ATtiny85. ATtiny85 is an 8-pin microcontroller. That's pretty powerful for what it is, for at least the era that it's from. It's old now, it's not that powerful, but it's fun to use because when you limit yourself with that many pins, you have to do some real tricky stuff in order to get all the functions of a microcontroller. Like if you want to have a bootloader that has a TX and an RX pin, or if you want to have, you know, basically functionality out of your pins, if it's not doing something that's purely digital, you need to have some kind of a reset implemented on it. And for the ATtiny85, you actually have to put 12 volts to one of the pins. So instead of just being a little 5-volt microcontroller, 3-volt microcontroller, all of a sudden you're coming in with this devastatingly high voltage and blasting the pin to kingdom come. It's great. And then you have to do things like releasing the reset pin from reset functionality into being an I/O pin, which is why you would need the 12 volts in the first place. Crazy stuff. Oh, I have some of those. I have some of the ATtiny like 6 or something like that. And it is an SOT236, and I have a ZIF socket for it. But I haven't been able to do anything with it because the ZIF socket is really weird, and I haven't like made a circuit board to adapt it yet. But it's really cool. It's a 6-pin microcontroller. What do you do with that? Did we find the pins? Yes, almost exactly what we were looking for. We've got like one more to categorize. I want to see PA10, which is pin 43. We need to actually label which ones are which. Hold on. PA12, 45. 45, PA, wait, did I get the right one? No, I didn't. Sorry, you guys might not be able to see it because I'm working under the chat right now. The other one is PA11, which is 44. I had to focus in and go hyper specific to the processor that we have, because its 64-pin pinout is a little bit different from all the other documentation that I was looking at, and that was the cause of 99% of the confusion that we were having. So PA10, pin 4, pin 69, pin 43, and its identity is alternatively timer 1 channel 3. And then USART1 RX. So that's not really, The cool part is the CAN RX and TX that I wanted to use, they're the USB pins. That couldn't be any more convenient for me. So what I'll be able to do when we take over this device and make it into an Arduino, which is now looking more and more inevitable. Man, I want to talk to Samsung, fly me to the moon and back, because man, they made a good product here. If you guys get a chance, I'm fully endorsing the Graphene MD13. And you can reference this to save yourself hours and hours of reverse engineering. But it looks to me as though we can get, I don't know if we'll be able to program it with the JTAG right now, but I know that we have access to the UART from USB. And with that USB having fallen off, we can take the direct outs from the microcontroller and we can plug them in to something like this, which is just a little CAN bus adapter. And that way we can have our 500 kilobyte per second kbps CAN bus, kilobit, I don't know, fuck it, come in here. We can have power and ground go to these things. Power will be clamped by a diode or static electricity protected. It'll have whatever. And then if it's 12 volts, the 1117 S33 can handle that. It's totally fine with it. I've seen it do it all day in musical devices. And then we can run the output from the LM1117 to this guy and have it talk to everybody else. And I wouldn't do it here on these pins. Unfortunately, that would have been a nice place to do it, but we can do it from the CAN bus pins, either over there at the socket, or I can just take the resistors out and do the whole thing just right here. Just drop that board right there, and then that's baked in. Beautiful. And then the rest of it, I have to resolve rows and columns. Ugh. I don't know how to do rows and columns. We have to do rows and columns. We also have to do muxing. And I'll have to put that together as a big piece of crunchy software. But now we know how to get into our device. So I can think about how to reverse engineer this and get a bootloader, get an Arduino bootloader on the thing. You can make fried eggs on it, but yes, how are we doing with... There's lots of vias on the ground. Not a very big plane on the positive. It does have ground plane beneath it that it can potentially bleed some to. I think all of this right here is for mitigating heat. Yeah, there's a lot of vias though. I think that'll do okay. Man, I gotta get a job at this company. They know how to make circuit boards and they know how to make hackable hardware. That's really cool. So the CAN, I guess what it'll do is it'll send out button statuses on CAN bus, probably go to sleep if things are too stabilized, and then when things start changing, it'll come back to life and keep sending out CAN messages. And I guess most of a packet will be dedicated to the buttons. The encoder's a tough one. Encoder right, encoder left, I guess maybe, would be what's coming out of that. The fader's another analog on the 8-pin mux, and then we'll have a packet that comes in that gives it LED statuses, and then this will instigate whatever the LED statuses are in its matrix of things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21. It's 21. I wonder if it's one per. 21 pins, and we're using up most of the pins of a 64-pin device. So they might actually be, that would be an absolute godsend. Godsend versus a god smack. I guess that's Charlie's thing. If we have 21 pins and it's like one button per pin, let's just get a close by button. So here button. Basically what they're relying on is a conductive rubber pad to bridge the gap between the two poles of the switch, and they just make a fancy pattern around it to look cool. What's up, Copper? How you doing? What up, Capper? So there's probably a local pull-up, because I don't know if there are internal pull-ups in the STM32. A lot of the Arduinos have internal pull-ups, and those are so convenient, because you don't need to have an extra resistor on your device. This one is... Okay, so we got... Oh, wait, is it Is it sensitive? Is it 3 pins? 1, 2, 3. Nope. Yeah, it might actually have some form of sensitivity. Unless this bridges all the way, because, oh, this is a loop. They just needed to get the line out over there. Okay. So it's just 2 pins. It's this and this. Funny thing happened while helping at a church. Godsmack appeared on the suggested music from Spotify. I haven't listened to that. That's Critical's thing, right? The moistened one. It's a song. I want to undo this tape. Where can I find like a clean one of these buttons so I can see what the output looks like? Let's look over here. Slightly different pattern, but we're connecting it to ground. You can see that's very clearly connected to ground. No, actually, there's 2 signals there. Oh, and they're doubling them up. Darn it. Unless that's power, unless it's a pull up. But that's not big enough to be power. It's not big enough. But it is going to multiple. Those are all the same thing. That goes to another place too. Oh, what are you guys doing with these? That's 3 in on that one. Ugh, can't. I don't have room on my desk. Oh, then it goes in there. So it's 1, 2, 3 in there. There's nothing. Oh boy, it's ducking under. So I don't know how many it's going to be on this. They could have cheated and have something come out over this way. This piece of masking tape, I don't really want to remove it. I don't know what its purpose is. Yeah, they're all bunching up and they're all coming over to here. And that's where they meet these resistors that lead to the outside world. And are they ground or positive? Cut the board in half. What? Huh? Power. On those anyway. I don't know about these. And then out to the thing. So technically, I think these are pulling down. What, did you say something weird? Funny thing happened recently while helping out. Okay, I already got that one. Oh, this morning has been dealing with cable management because a power bar came in. Not done, but in a state where I can use my computer again. Why was that auto-modded? That has nothing. Held a message for using channel blocked terms. Did I block not done? I might have blocked not done. I might have been that petty. A power bar came in, not done, but in a state where I can use my computer again? I don't know what the term was. I don't think I blocked not done. I mean, that would be just about as petty as I normally get. But this is the original message that Copper tried to type. And it, okay, so it's not done. Yeah, why is BTS not done? That I would have like set off a light or something. I don't think I'd auto-mod block it. Morning? No, I don't like the morning, but not that much. Dealing with cable management? No, that can't be. BTS, no. Cable management? Not done watching. Yeah, so deal with, I can use my computer. Oh, and then it got it again. Held a message for using a channel blocked term. Allow will post it to chat. Oh, Resident Sleeper. Resident Sleeper, because Resident Sleeper can be used really toxically on this channel. With what we do, using Resident Sleeper is like super rude. So that's what I blocked. Oh, that took us a while to decode. I don't think I've used Resident Sleeper in a chat in a while, but it's just super toxic. No, it's not. No, we specifically blocked Resident Sleeper. Syphilid8 subbing with 61 months. Holy shit. 61 months. Thank you, Syphilid8. Thank you very much. I really appreciate you. Why is it toxic? Because it's a guy falling asleep. And the stuff that we do here is like kind of cerebral. So you could post that to say that I'm being boring. Well, I'm always being boring. And if you think I'm being boring, you can go somewhere that's not boring. That's on you. I'm so not up with the things. No. Well, why? Why would you, like, I'm going to go watch Twitch today. Let's see what this person's up to. This is boring. I'm going to tell them it's boring. Why would you do that? It's like, I saw the puddle of water and I walked in it with socks. Why did you make my socks wet? Like, that's what that is. Idea, don't be boring. What? Have you seen what we do here? Wait a minute, that's not the way I want to do that. Move that up, move that up. Just move the whole thing up. Let's just move the whole thing up. Clean this up. Oops. And then you guys come up here. Whole thing. Moves up a little bit. You can move down. That. I move that fan and now it's like super hot. Not fun. Save that. Actually move that in a little bit. This is what I used to do for a living, just not an MS Paint. It was cleaning up schematics like this, largely. A lot of other stuff too, but this is one of the facets of that job, was cleaning up a schematic so that it could be read by intelligence people. And being consistent with a style guide. Now my style guide, the styles that I follow are a little different from the other ones. Like I like my hand-drawn aesthetic a lot. So, and then if we wanted this to be more clear, at PAIO, I don't know what it's doing. I don't know why they would double up on the USB this way with a big resistor. I don't understand what function that would have inside of the microcontroller. PA10. Well, actually, PA10's all the way over there, but it's still the same thing. It's I should move the PAs over. Peow! I'll get to chat in a second. But yeah, it turns out if we had focused in on the correct chip, we would have had it fine all along. It is doing exactly what we thought it would do, with the bonus that the USB pins, the D- and D+ for USB, also serve as the internally, whatever, the actual CAN bus capable microcontroller pins. I don't know what that means. I don't know what that means. Does it use a CAN like UART, or does it do it directly to the bus? It would be kind of cool if it went directly to the bus, because then I wouldn't need that extra chip. Although I would not trust an STM32 chip to go directly to CAN. Normally it's to tell the host that the host is a full speed device and it should communicate at that speed with it. After enum, it's floating. After enumeration, it floats. Oh, so that's so that they can assert like a high or a low on the pin. Oh. Hold on, I got to reread and make sure that I'm absorbing the information from chat into my ADHD brain. That is possibly the worst double up ground that I've ever drawn. I'm going to leave it. This is BotherCAD. The only sense that this is EagleCAD is that we're in America. As the eagle flies on the mountainside. The CAD program that I do use is Eagle, and Eagle has a distinctive look to it. I used to use something called, oh God, no, wait, I don't remember what it was. It wasn't SirCAD, but it had its own like flow to it. It was a very interesting CAD program made by one guy in Florida. And apparently that's enough for him to get multiple government contracts in order to make the CAD program that fuels an entire unit's worth of data coming out. That must have been a sweet fucking gig for that guy. Holy shit. Selling licenses by the bushel to the government. It was a cool little program though, because it was very minimalistic. It wasn't Notepad minimalistic. It wasn't, you know, whatever, MS Paint minimalistic. It was sort of its own thing. It was CAD still. But a lot of the tricks where I take like the lasso tool and I'm going around stuff like this, I was doing that, but with like components in a real schematic program. EagleCAD is a little bit different. The function of EagleCAD is not really necessarily to explain to other engineers what's in your circuit. Now it does that. It does that fine. It does that well enough. All the color coding and stuff on it though, the government price $500 license. Yeah, for the premium government edition. The one that has secrets in it or something. Yeah, but so with EagleCAD, what you're trying to do is you're trying to communicate to your circuit board drawing software what connections are being made. So you don't necessarily have to follow all the conventions that I follow here. And sometimes I will skip things, you know, in terms of like how I specifically draw schematics. But for this, I'm being sort of a stickler to how I draw things. Now, most of this, the schematic is not really the star of the show here. I'm not drawing a lot of resistors and capacitors, right? That doesn't matter that much. Really, the important thing that I'm jotting down here is what do the pins do so that I know how to hook this up to a programmer and then program it in order to, you know, change what the microcontroller does. But the rest of this is going to be a big... I know EagleCAD, but my brain is hearing EvilCAD. And now I have a life goal. Hey, we just made a new piece of software. Welcome everybody to the birth of EvilCAD. Do I really want to draw the chip like that? I don't think I do. I don't really know what I want to do for the rest of the pins because there's a lot to do here. Let's trace one of the LEDs and see where that's hooking up, and maybe we can discover a trend. Because my concern is that we have like a typical, like, here, check it out, like a button matrix. It doesn't seem like we have, there's so many I/O on this thing. We have what, 64 pins? Like PA goes all the way to 14 because it's A, B, C, D, E, F, right? Because remember, in microcontrollers, everything is an address. And it's a bit and a byte, eight ones and zeros, right? So when we have banks of pins, if we're like a maximal device, well, something that has tons of I/O, we have bank A, PA, 0 through 14. PA 0 is a pin. Hold on, I'm checking. PC 0, yeah. PC 0 all the way to the 8th, which gives us a hexadecimal number, right? Or is it the second or the, I don't know, my bit counting is all over the place. The point is it's in hexadecimal, so your banks go up to pin 14, because that's 1 through 10, A, B, C, D, E, F, right? Because it would be A, B, C, D, E. Or it would be rather A, B, C, D, yeah, whatever, fuck it, there's no G. So if we have bank A, bank B, bank C, and bank D, although PD A, B, C. Yeah, we got A, B, and C. But PC looks like it might be the analogs. C1, 2, 3. So 4 banks with 15 pins. Yeah, we could probably just look up what the I/O is because it's all over the place. Because look at that, PC is over here, and then it's over here. It's like they use PC for center. Buto. I'm just wondering with, okay, so let's look up how much I/O these things have. What are the specs? Oh, microcontroller datasheets are the worst. What? USB, CAN, P to 280. What is this table trying to even communicate to us? Oh my God. Who opens up a data sheet and looks for this diagram? Oh yes, of course. Jeez. 32F103R. GPIO 50. You have 51 GPIO, right? 51. 51. So let's see if we can get to 51 here. Let's see if we can get all the way up to 51. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 for your analog, 27 for this. No, wait, that's all already on this. 26, 27, 28, 29, these are LEDs. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 50. 51. 31 footsteps, 32 footsteps, counting for the road, counting to the where the road meets the sky. 32 something, dancing in Indian headdress. 32 blue moon, something, 32 skies. This is a They Might Be Giants song. What's the reason? I don't know. Where's my baby? Okay, anyway, shut up. I'm getting all the lines wrong. So it does look like we need to matrix some stuff. There's a little bit more I/O considering we can't just have 1 pin per thing and 1 pin per LED, unfortunately. We have 7 analogs, which fits on the 7400 series, which takes up 2 I/Os for its 2 pins. We have USB, we have our UART, which might be shared with some of the rows and columns, and then we have rows and columns for both the LEDs and the buttons. STM32s should have 16-bit I/O ports. They're not all brought out though, which is the biggest gripe with them. Oh yeah, it's the different packages, whatever you can fit in your design. In our case, it's the R, the type R of STM32F103s. That thing is so fast. 72 megahertz? You kidding me? 12-bit synchronized ADC, number of channels, 2. Which ones are those? Well, they're probably the ones that are hooked up to the 7400 series chip. Are LEDs data line? No. These are... That would have been sweet if they were on a digital line. These are just red LEDs. If we do the diode tester on them. Diode tester. You guys remember that TV show? Diode tester. It was a cool show. They do nothing? Wait a minute. Nothing? STM32H with 500 megahertz and 7 cores. This thing has 4, I believe. 4 cores. What are you doing with that? What are you possibly doing with that many cores, man? You're embarrassing us. Negative 1.2 volts. Or no, 1.2 volts. The diode symbol looks like a minus. Why aren't you lighting up, though? There must be some other electronics at play here. I mean, I don't know about lighting a single LED from a matrix. This should illuminate with the diode testing function. That's one of the uses of the diode testing function, is to figure out where the anode and the cathode of the diode are. A plus, C minus. Weird. Weird. So where do these LEDs go? They each have 2 terminals on them. Power to something. We're back in the big lineup. So this trace is a wide trace, and it appears to feed all of the LEDs. And then it goes blah, 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 blah. Ha, 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 ha. Like the Perpetual Dawn song. That looks like 3 volts. Because that's the other bank of LEDs. Yeah, so we're coming all the way back. Let's just go from the big boy over here. Oh wait, I put my meter away, because if I leave it on the desk, it'll pick stuff up with the big magnet. So we got ohms. But MELF. From there all the way to, hold on. Yeah. Big one all the way over here. 2. Oh, it's over here. The center pin. Yeah, ohms. That's on the tab, which is the output from the 1117. Okay, so yeah, that is a power line. So the LEDs are being pulled down. So that we would know as looking like this. And then we'll have an LED that I could probably cut and paste. That goes through a resistor. And I don't know what else, because we haven't looked at that part of the circuit yet. Take that, put a couple on there just so that I'm displaying what's going on. And we'll see if we can figure out what the rest of the circuit looks like. It's possible that they're doing this the same way that like keyboards do, where they actually matrix everything, and so they'll go through and pull the LEDs, and those will just turn on with everybody else as they hit grounds to the pins. The sound of my high voltage probes scraping on the floor is the same sound that spiders make in Minecraft. Oh boy, don't know where that's going. Oh wait, there to there. And then back in through a 100 ohm resistor. And then what are these doing? Okay, so I'm gonna have to do a bunch of more reverse engineering before I get this done. It looks like we have some of the right parts that I might be able to like just take it over directly. But I'm not totally sure about that yet. What did they say in the tutorial? What did they say in the tutorial that we needed to hook up? 3 pins. Reset to, oh no, SW clock to SW clock. SWDIO to DIO and 3 volt to 3 volt, ground to ground, you only need 2 pins. So we might be able to actually throw one of these cores onto the thing directly if it's not locked down. And I guess we'll try to explore that later. I am going to end a little bit early today just because we've got a bunch of dogs upstairs and I want to make sure that I'm doing my part and taking care of them. So I'm going to probably raid you guys into somewhere, all 30 of you. It says 40 on there, I know. Let's just see who's around. I don't want to do too much of this boring stuff. This has been like a really cool sort of fact-finding mission that I didn't expect. I was going to be over here messing with actual physical stuff and putting all of my 3D prints in there. I can probably figure that out on my own. That'll be a bit sweaty and weird, and you guys wouldn't have been able to see chat. Reverse engineering a MIDI pad is really cool though, because we can now, like, this is more than perfect. This is everything that I was looking for and more. The only cooler thing that could have happened, you know, like Daniel and the cooler Daniel, the only cooler thing that could have happened would be if 1 button per pin, but with 21 buttons, that gets to be a lot on something like this. We have a multiplexer that we need to take over. We have an AB encoder, matrixed buttons, and what I think are matrixed LEDs. Not totally sure about that, but getting to the bottom of that is going to be a lot of tedious tracing of various pins, and then the whole thing will kind of start to make more sense once I get, you know, for instance, the pins for the 7400 series dealt with, the AB encoder, figure out what the matrix looks like. Maybe it's 2 rows. I'm not sure. I'll have to do a little bit of probing around on that. But the more we can characterize this, the faster this will become its own independent device. And then I can see whether or not we are capable of loading Arduino into the thing, and we can see whether or not we can get a button push. And man, that's cool. That's really exciting. I did not know that that would be so cool and easy to hack. I have a feeling that on later versions of it, it's probably going to have a more, not proprietary, but maybe a less consumery microcontroller. We still have the R8, the STM32 F103 R8, the very easy title with these STM controllers, may still be like kind of proprietary. They might put in some weird version of it. So yeah, I don't know if the later versions are going to be as easy to just hack. Boy, Raba's still doing Drain Sim. I guess that must be an interesting one. Oh, Flatulent Gonad is on. Let's go ahead and hit up Flatulent Gonad. Paulrin's on too, but we'll just raid Gonad here. Thank you guys for joining me. Yeah, I really appreciate it. We went off in a weird direction, and I think we succeeded in finding a really, really hackable input device. I'm super happy about this. This will lead to a lot of crazy stuff. And I'll catch you guys later. I'm going to take the dog out before we lose sunlight. Wintering the cars. Yeah, he's currently wintering in Finland. All right, let's go raid. I'll see you guys. What are you still doing here? What are you still doing here? Are you still, you get your little hacky twitch and said no to the raid? How dare you?